Alright, let's see what's going on here. We are going to get started. Let me get one of these going. Just so we have some... Get this going, just so we have something right here. In the background of it all. And you guys can see some talking. Alright. We'll get started here in a minute. We're going to do some Loki work. We've got something to fix in that lab, so that'll be coming. And you know what? This music is too quiet, so we're going to pick something else. Let's go do... I guess we'll do Stream and Chill. I think it's a good starter song. Virtually Pet Ranger for a second here. I went downstairs and gave him a treat earlier, and I gave him. He had soft food today. He gets soft food once a week. He has hard food for his teeth. It's good for his teeth. And he always gets hard treats too. He gets a few soft treats for his joints. But. Alright, let's get this going. We are going to do Loki monitoring. That's going to be our next lab. So we're doing all our Linux stuff. We're going all the way through it. Then we'll do all our Ansible next. We'll get through whatever we get through tonight, and we'll get into the next part. Yeah, I think I have everything the way I want it here. Let me see. This is me here. I got some other projects we could do tonight too, but for now we will keep up on this stuff. Alright, so our next one is Grafana monitoring and Loki, and I'll link this one for anybody that wants to do it with me. You guys can do the lab with me in real time, and there's a couple of fixes in this lab that I actually have to maybe do live, but I'll show you guys how to fix them as we go, so we may have to add those in. Because when I did the lab earlier, I did this lab in our little break time there, and this thing was just gave us some problems. So there's a couple of things that I might have to do, and we'll figure it out, and then we'll fix the lab around that. So, all right, let's go. So welcome to ProLug Configurations. Again, we're in the configuration part. Your team has determined they need to offload and monitor Linux logs in your environment. You know that Grafana can do that as a visualization tool, so you plan to deploy it on a server as a daemon. Deploy Grafana and ensure that it is running on your server. So, there's some Grafana docs if you want to go read them. We're going to install a couple of required pieces of tools. There's apt transport HTTPS, and then software properties, common and wget. So we'll get those, get them installed on our box, and then we'll go from there. And we're going to add the GPG key for aptgrafana.com. And after we have this, we're going to make sure that it is signed into our Etsy apt sources list, grafana.list. And then now, anything that we download, we can verify that it was signed by that key that they've given us. They've given us the public version of it. They've kept the private version of it. And we can verify that whatever it is that we download was signed by their key. 1 second. Oh man, I did not mean to be sneezing. I was just outside a little while ago. I went and got some food, and I got our mail. Man. All right, so get Grafana going. We're gonna start it up. Grafana is not one of those services that starts by default. We're gonna have to start it right here. So we'll start up Grafana, and then we're going to make sure that when it's started that it's listening. And Grafana takes, I think I've told you guys, it's about 10 to 15 seconds to come up, even though the process is running. it takes a little while to get to listening state. So we'll give it a second, and there it is. Now it's listening. So that's good. We'll go check our dashboard. There's our port. There's our Grafana coming up. We're going to log in as admin and admin. And then we're going to get into there. And yeah, of course, you shouldn't have admin as your password. So we're going to set it to 1, 2, 3, 4, 5, 6, 7, 8, which is super secure. Oh, jeez. There we go. Never. And there we go. So we've got Grafana ready to go on the lab. Now this next part is where it broke earlier today. So now we're gonna, your team has decided to log with a log aggregator, a tool called Loki. So we're gonna do that. Your job is to get Loki up and running on your server. So install Loki, verify Loki is running and exposing port 3100. All right, that's pretty straightforward. Make directory op Loki, cd to op Loki, and then here, this is where we might be getting in trouble. We're gonna download version 2.9.4 of Loki. And then we're going to download also, right at the end there, we're going to download the config for Loki. And what I suspect happened here is that we've got an older version of Loki and this newer config no longer works for it. But we're going to check that here. So we're going to copy over the daemon to start it. We're going to check the local config. And everything in here is right except for this front end encoding protobuf that's not used anymore. So when we go to start Loki right here, we're going to enable it, and then we're going to go look, and it's going to tell me it's busted. So just for right now in the lab, just for right now, we're going to vi etc, opt Loki, and then Loki local config.yaml. And all you need to do in this lab for right now is just comment out this front end protobuf. We don't need that crap. But for me with the lab, what I need to do is this. This is what I need to do. I need to come here, and I need to look at the version that we downloaded, which was this one. And I'm going to go to the, right here, and I'm going to go look at what version, what versions are there. And there's 2.9.7. It's the most recent version. That's weird. Isn't that what we say we're downloading? Oh no, we're doing 2.9.4. So let's back this up again real quick. Hold on. I'm gonna undo some stuff in this lab for just a second, and then I'm gonna go fix it if I need to. I'm gonna rm-rf the Loki local config because I made a change to it, and then I'm gonna rm-rf everything. I'm gonna blow this whole effing directory away, and I'm gonna change this right here to say, all right, download 2.9.7 Loki, right? 2.9.7. So now we'll have that. And then I'm going to say unpackage it, which is that next thing. Unzip it, right? And then I'm going to say make it executable, which is right there. And then I'm going to say download that original file. I'm not going to change the file in any way. Here, this is the Loki local config. So now if we look at the directory, everything's right. Now I'm going to restart the service. Let's restart the service. We'll just restart. And if it starts, there's still a failure. So that is, to me, let's call it, let's stop it. Okay. And then we'll start it. Still failed. Okay, well then, what I thought would be a fix was not a fix, because, yeah, there we go. We downloaded 2.9.7, and that's the version that we should have here. All right. 2.9.7, and we download the new one, and it still didn't work. So that's fine. What that means is my fix isn't going to fix it. I'm just going to have to tell people to comment out the protobuf, which are these two lines right here. Who knows why their config is busted, but their config is busted. and we just verified it against their newest version with the one version of their config you can use. So let's start Loki, status Loki, and it's running. Okay, so in my lab, here's how I fix the lab so that the next group of you guys that come through the lab don't have that problem. We're gonna go here. Oops. Here's how we do. I have something going on with my VS Code where it crashed today twice. Once I didn't see it and once I did. So that's super effing annoying. Also, having to open folders kind of pisses me off because I've had all these folders open for a long time, and that's super annoying that they're going to make me go find... Oh, motherfuckers. I've had these folders open for so damn long. I don't even remember where they are. God damn it. I don't even remember where these fucking folders are, guys. Alright, Prolog Labs, Prolog website, those are definitely two of them. HPC deploy is one of them, AWS work is one of them. Alright, yeah, they're all in here. So Prolog Labs, and yeah, there we go. Yeah, I trust the authors, you motherfucker. I'm the author. NeoVim never crashes. Yeah. Fair enough. I don't mind, and I don't mind using Vim inside of a tool. I actually only use this because some of my coder friends told me that a lot of people are using VS Code, and I'm like, I'll see what's going on with it. I'll check out what the cool people are doing. All right, here's our Linux labs right here, and here is our Linux logs, and here is this first. This is our second step here. And here's our text, and we're gonna go fix Loki, which is now 297. And then all that can be the same. But then I have to say right here, you're going to need to comment out the 2 lines in etc and opt Loki. What the hell's the name of it? Loki local config.yaml to continue with the lab. So the lab, that'll be plain, and the 2 lines are going to be these ones right here. Where the hell's that at? Right here. Where the hell's that at? These 2 lines right here. So comment out those 2 lines, and then you can continue or whatever. You can create environment variables so you don't have to look for them. Not sure if it's worth the hassle though. Oh, I didn't even think. Yeah, I just once I have things open, I leave them open, and then I forget how to use the tool because I don't use the tool enough. So that's my problem with. I mean, shoot, damn near everything in my life. Is that I don't even think about it. But it makes me so mad that this crashed because now. I wonder if this is actually just going to push or if I'm going to have to go figure out my credentials and all that crap again. Anyways, fixed error in lab. Let's just do this. Sync changes. And hopefully, we've never had a problem with this lab before, with this push before. Hopefully it does push. All right, there we go. I'm gonna be honest here, guys. I don't know if this is taking. So now, God damn it. That's fun. All right. I need to. I could just use VI for it, but it's super. It's never crashed before. Here's all our Prolog labs. I just gotta go see if that took it. Fixed error in lab. Okay, so it did take it, even though it then crashed immediately. Absolutely annoying. Text.md solution. Wait a minute. Why is this? Oh, jeez. It did not. Why did that not take the? Well, it should have been fine. All right, let's go. Let's. I don't know why that looks like that. Frustrating. Frustrating. Why does that? Motherfuckers. Yeah, I can definitely see me moving to a new tool in the future because that's definitely going to piss me off. All right. Anyways, let's continue with the lab. We fixed it manually here. I'm not going to restart the whole lab just to figure that out. It's running. It's good. That's fine. We'll move on to the next part. So, I feel like this is me right now. This is me right now. We're doing it live. All right, any research, you find out that Promtail will push stuff over. So Promtail is a tool that will push over any... Dude, what in the fucking fuck? Fuck out of here. Fucking piece of shit. All right. Okay, anyways, here's the information about the lab that we're kind of doing. So anybody that's trying to follow along and figure out what's going on with this madness, that's kind of what's going on in the lab over there. So we're gonna push Promtail over there. Yeah, everything. I'm just this is me right now, doing it live. Whereas this is also me right now. All right. Anyway, so in our architecture, we built Grafana. We've got Loki in there now in the middle, and Promtail is going to push to Loki for us. So let's do all that stuff real quick. So we'll make Promtail, we'll CD in there, we'll download the most recent version of Promtail. 271 will do everything we need. We'll copy over this basic little config that I made that is pointing at the scrape configs for varlog syslog and varlog auth-log. If you were doing this in a Red Hat box, this would be varlog messages and this would be varlog secure, right? But we're in a lab, so we use the stuff that we have, but it's just good to kind of note. We're going to copy over. There we go. Okay, and then we'll copy over the service, which is the Promtail service. This is the simplest little startup that you can have. It says to start it up, all it does for the exec start is call the service and then call the config file that we made. That's it. And then we're just going to start that up, and then we'll go look at it and make sure that it's running. And we feel pretty good that the service is running, so we're good. Let it check. Now the last thing we need to do is go jump over into Grafana and set up all the pieces so that we have the configuration running all the way through. So again, Grafana's sitting over here, Loki's sitting here as just an API endpoint, and now Promtail's going to start throwing logs at it, and Grafana's going to start pulling information out of it. Okay, that's our workflow here. So we'll come over here to connections. By the way, everything I'm doing here, it says right here what to do. Go to connections, make a data source for Loki, make it point to 127.0.0.1.3100. That's the default. And then we're going to make this dashboard, and it tells us right here exactly how to do it, right? So I'm just going over here. I'm going to say Loki, right? New connection or data sources, as they call them. And we're going to say make a new one. We can call it whatever we want, but Loki is simple. And we're going to make sure that it's 127.0.0.1:3100. There we go. Boom. We don't have any authentication set up or any services. One of my favorite things about Grafana is if you're about to hit this button, when you hit this button, it tells you, good job, bro. It's like that little, you guys ever seen that little kitten that's going like this in that meme? That's what it's like. It's like, you're good, bro. So we're good. We have that. So now we're going to go over here and we're going to go to dashboards, and we're going to import this dashboard by its number, which was 13669. 13639. That's right here. 13639. And we hit check, and then that's good. let's come back over here and we'll load up this dashboard. 16369. 13639. What is it? Oh, you can't have a space in it, guys. It'll break. You can't have a space before it either. That'll break too. So it's very literal. And here's what it does. It says, hey, this is the one I downloaded for you. Name is logs apps. The folder, you can put in any folder you want. And then your Loki data source, you can just connect right here and hit import. And then what will happen is, look, there is immediately our auth and our syslog for our system. So if I go to our auth log here real quick, I can set this to refresh every 10 seconds for me. And I can come back over here and I can just do like a silly little for I in sequence to 100, do user add -m some user $i, right? So it'll do some user and then count through a number, and then sleep 2, done. And if we run that, it's just going to make these users. And as it makes users, it's going to throw it into varlog offlog. And then if we come over here, we're going to see some user, and this is just going to keep incrementing every 10 seconds or so when this refreshes, of some user that's being populated in our logs. So now the logs are coming off of this server in real time, going to the Loki server, which it's not lost on me that it's all on the same server, but in an environment, we would be launching them somewhere else in the network. And then now we would have what we call log aggregation, or some people like to call this log offloading. We are sending things off of the server in real time, and then they're going somewhere else, and then from that somewhere else, we're querying them and getting them into Grafana where we can see these logs. By the way, this is just some generic thing, but in my Homelab, I have one of these. And this this looks at secure with failed, and this shows for the last 6 hours. These are all the people that have tried to log into my home server here. My server that sits out with SSH to the world. These are all the user accounts that have tried to log in the last 6 hours. It's a lot. It's a lot. It would be even more if they weren't all botted and locked out, because we have them getting locked out forever. We're up to 37,000 that have been locked out forever right here in the last 90 days. Well, actually, they've been getting locked out much longer than that, but we're at about 37,000 that have locked themselves out forever, right? So, let's come back over here. Once you've done this lab, it says that you can play around with whatever you want in here. But there's another piece that, funny enough, I don't even see here, which I thought, well, I don't even, are you going to break all over the fucking place, or are you going to work, you know? Yeah, see, there's this step 4. And this step 4 never got added in. Maybe it did. Oh, step 4 did get added in, but there's a thing that I added to this one kind of quietly without telling anybody. Let's see if this crashes again. What a piece of fucking shit. Anyways, get out of here. We'll stop this. There's a little thing that I added in here. So if you do this lab with me, I added this piece down in answers, and I didn't actually add it to the lab. It's just in there. And what it is it's a Loki write in Python. And this is a super simple one. I use this in my Homelab. For any time I want to write something, then this is all you need. In Python, you need to import requests, because you're going to be using requests to do a post to a database, or to a Loki, right? It's just an API call right here. Look, HTTP 127.0.0.1 API prom push. That's the name. And you're going to use requests after you build this to push that, right? Import JSON, because we're going to be using JSON or JSON. And then we're going to use date time and pi time zone. The host is going to be control plane. We've got some current time data that we're going to pull out of date time, right? We're using date time to pull that. And then we're going to build this little message. On server host, detected error, Scott is too awesome. That's my error. Then we're going to build our URL and our headers, and here's all our payload right here. Right, here's all our payload. Whatever we're going to send over there. And then down here is where we send it. We say answer equals whatever, and then print answer. Where do we send this? Hold on. Yeah, requests. So answer equals request.post URL payload headers. So we send all this information over the headers and the payload we send over as a request.post for the request tool, right? And if we just do this, watch this real quick. We'll say Python 3, and then what the hell was this one called? It was Loki write.py, and it'll tell us 204. 204. We got a response back, right? Hey, Less Than T, how's it going? We are doing some stuff. Now check this out. This is refreshing, and we stopped at user 70 because I stopped it earlier. But now look, we only have these two values, auth and syslog. But I just made a third one called like lab logging or something like that. I don't remember what it was. But let's look in here, and there it is. There's lab logging, and there's Scott was too awesome at whatever time. And it's called forStream. That's the variable that I gave it. So now we could take this little Loki write, you know, anybody that wanted to, and you could modify this to just be, like whenever my buddy Salty's on, Salty Catfish will be on sometimes, and he'll show like logging to a file and doing whatever with his applications and stuff. But what if he was going to take that application and deploy it to like 20 servers? And he doesn't want to go hit all of those logs and deal with if his stuff got installed right and all this other stuff. That would be a kind of big hassle if you ask me. So what he might do is he could just put this in, and then he could just build his message for whatever he's going to do, and then he can send his messages instead of logging locally on a machine. He's just basically throwing them at this Loki server and just launching, or as the younger guys call it, yeeting shit over, you know, like yeet the stuff off the server. However you want to get it off the server. The point is, we now have a way to get that all the way through, all the way until we see it over here on this other node, right? So this is very, very potentially valuable to you as a systems engineer and as a systems admin. I never have to worry when I'm launching everything off my server to Loki like this, all my logs. It doesn't matter if somebody ever gets in and then goes and wipes my logs. They were being sent off in real time. It's kind of like when somebody like walks into somewhere and they're already on camera. So now it's like they have a choice. You're already being tracked. What are you going to do? Oh, is it? So when I first built it, you're probably right. I don't need the PyTZ. Oh, I could do it without the PyTZ. Guys, you got to remember, I don't code, like this is as much as I code right here. Like, and most things I steal off the internet in some way, shape, or form, right? But no, this is, yeah, so I can pull that off. Okay. And then it's also in Asia time, so I probably want to change that anyways. Well, yeah, this is a way to send more information up to your servers, because at the end of the day, we can send as much as we want to, right? We can do a lot of stuff with a system, and again, I'm mostly the guy that builds the system and lets the other guys come in and launch all their data and do all their smart coding stuff. I'm mostly just the guy that tests it and makes sure it works the one time, right? So yeah, there we go. Look, that's the lab. And then over here, I said, why did we download and set the GPG key in our apt repository? What benefit do we get from that? Well, we know that whatever is up there in that repository is unchanged from when they first put it up there, because they signed it with their key. Why did Grafana take about 10 seconds to start listening on port 3000? Because Grafana's lazy. That's the technical reason. No, it's just some applications take some time to get their listener up, especially their first time. It says, why does Loki.service say that it should start after network online target? So when we do, we can see right here, systemctl cat Loki, right? It'll tell us right here that it's after network online target. Well, that makes sense. If I'm going to have a service that's listening, right, it's an API that's sitting there listening, then it's going to hopefully be able to come up after the network online target, because the network needs to be up. Hey, Loophole Lou, how's it going? We're just hanging out today, just working on labs pretty much all day. The wife's out of town. She'll be back tomorrow. So, and then we're kind of short timers, because Friday we're leaving for Mexico we'll be in Mexico for a week. So that'll be kind of fun. So what logs do we configure and send to Loki within the Promtail service? We did varlog auth and varlog secure. Varlog auth log and varlog syslog. That was only on the Ubuntu style systems. On a Red Hat system, my system here, so my Homelab here, my Promtail, if I CD to opt Promtail. And by the way, it's funny, you might notice all my stuff in my Homelab is exactly the same stuff that I put out here for all this other stuff. So more Promtail, local config. In here, my scrape config is messages, and that's varlog messages. That's all my system stuff. And then secure is varlog secure. That's all of my login type stuff, right? Does that kind of make sense? So this is my Homelab. And this is literally, this one right here is literally the one that's feeding this right here. All the attempted logins. The one that's feeding, you might say, well, is this the one that's feeding over to the fail to ban information here? And I'd say, no, fail to ban is coming from Telegraph, and that's going a different way. In fact, this is all coming from numbers in a database, in a time series database, whereas this is actual log entries that have been thrown up to Loki. So I have multiple ways, and you know what's really funny? Really funny about this stupid thing crashing is this was not crashing earlier. Well, that's one thing that's funny about it. And two is I was showing something with Excalidraw on here earlier, which Excalidraw has always worked just fine as well. Yeah, my stupid fucking... Alright, anyways, where's that picture? Where's that picture at? Hold on. I think I have it right here in... I think it's my most recent one in Excalidraw, yeah. Yeah, there we go. So, if you guys have never seen Excalidraw, we can share, I can start a session, and I can copy this link, and I can give you guys the link. And the link is almost always busted, you'll have to copy it, but you guys can actually come in here, and then you can change this in any way you want, and then you can keep your own copy of it. And then I won't save my copy, but if anybody needs this, then all you got to do is go here, and then just export to or save to on your machine, and you can save a copy. But yeah, it doesn't, like, you guys can break anything you want in there. And if you've never played with Excalidraw, it's super easy tool to use. Super easy tool, super easy to kind of move around and, you know, draw things. And then you can draw things by hand even if you want to, right? I got my little stylus here. I can draw, right? And I can also control Z it all. Get rid of everything. But anybody can connect to that if they want, and then verifiable force, you can change whatever you want and you can save it or whatever. Alright, let me get that out of the way because I always worry about what's going to happen on stream once I share that out. What is the name of the configs in Promtail to gather log file data? That's a scrape, right? That's a scrape that we were doing. And it says, is the client that Promtail pushing to the same port that Loki is listening on? Yes. Do you think this would work if those were not the same? No, of course not. You're trying to throw data to Loki, but look, you might look at that and go, Scott, do you really have to ask that? You got to remember, guys. Sometimes people that are like learning systems, they don't know that everything has to line up for it to connect. They've never done it before. They don't know a port 3100 from any other port out there. So no, if the things were not pushing to the same port that Loki's listening on, this would not work. And that kind of makes sense after you think about it for a second. You're like, yeah, well, yeah. If I took a road north out of town and you told me you were waiting for me south out of town, we're probably not going to run into each other anytime soon, right? So there's that. Okay, so digging deeper, go to this link here, work through some of the data to practice on how you query Loki. So here's the Loki query language. And if anybody's messing around with Loki, they've got some pretty good like query type stuff in here. And then one of my favorite things they have is a little analyzer. So you could take this, you could dump out all of this garbage information, right? That they gave you some BS information, and you could come over here and you can grab these, right? You can actually grab all of these from like my Homelab. I don't care if my data's in there. Don't do this with work data typically. Like I wouldn't do this with your work stuff. But in my Homelab, I literally don't care. And then now I can actually test my queries down here that maybe I went and read about, and I can test them and see, are any of them gonna come out good, or are any of them gonna be ignored? Literally everything's gonna be ignored there. But what if I were to come back here and say, instead of log format, I was to say something like P01 jump 01, and then I was going to run that query, and that won't do anything. But I think I have what's my match right here? What's my matching? It says log queries, metric queries. Here's a log query. Let's go look at that. And it says something like, that's something like typically P01 jump 01. So let's go back here. Where the hell that? Oh shoot, I don't know where I'm at here. Back to here, back to here. And something like, right? So here's my query, P01 jump 01. Right? Run the query, it's giving me an error. I think it's more like that. Let's see. Maybe I'm doing that wrong. Line filter, label filter, parser. So query equals. Yeah, let's just do equals. Let's just try equals. Right? Oh, well, it would probably help if I also put quotes on that. Now, here's all the lines. It wasn't going to find some of those things, but it did find these lines with the P01 jump in it. So those are not being, anything here is being ignored, right? So there we go. We found P01 jump 01. And then maybe I look for, let's check, let's change that to root. I only want root information now, because I don't care that somebody tried to log in. I care that somebody tried to log in as root. By the way, in my Homelab, it doesn't matter. Root can't log into SSH. But now we only found the root information. So that's good. And all these other ones that were for invalid user admin and VNC and admin and Vivec and Alpha and Yangji and Alpha and Postgres, those are not found in this query if I were to query and try to show these. So this is like a tool that you can use. I linked it from you there, or for you guys there. You can go look at that and play with that. And then here you go. Nobody's even messed with this yet. I'm very surprised. Normally there's more messing with that if I post that in chat. But that's in chat. You just have to fix the URL when you put it in there. All right. So again, you've gotten Grafana up in this lab, you've gotten Loki up, and you've gotten some kind of ability to launch things over at Loki. And Loki is literally just an API that accepts the stuff that you throw at it and puts it into the logs. That's all it does. And then it allows something else to connect. You may have noticed, for people that were paying attention to this, maybe some people paid more attention than others, maybe some people didn't care. Let's go look at our Loki here, again, in our data sources. We'll click on this, and then I want you guys to see that if we look at the one that's already there, this is built in, has that, let's go back to connections. Where's the one that's already here? This is kind of annoying. Home. Data sources, here it is. So here's the one we already built. I wanted to show you guys something. I didn't do any of this, but if you had TLS settings and you wanted only certain things to be able to communicate with this, and then you were going to generate the certificates yourself and put them on the server and then go put them on another server and have that server use that to connect, you could 100% do that, and then this would only respond to servers that had that TLS cert, and it would only, you know, allow data to come in and data to be read off depending on how you wanted to do that. So there is a lot of security built in on this if you want there to be. You don't need it, but, you know, for the lab and stuff, but when you actually go to do it, you can set up all kinds of authentication. No, I wouldn't use basic authentication of username and password. I would only do either an OAuth identity where somebody can get a token and read and push things, or most of us as systems people will do TLS stuff. And I got thinking about this the other day. I'm gonna do one of these labs that shows you guys how to set up TLS certs, because you can generate your own cert and then just keep it secret and then pass the other one everywhere, and it's pretty easy to do. Well, easy. It's straightforward to do. Let's say you just have to do it. Once you see it once, you're gonna be like, that's it. That's the cert stuff. It's not super difficult. We just have to spend some time with it, right? All right, but here's some questions. Go to that link, and then use in the enterprise log should be pulled off systems in real time. They should represent immutable events that can be queried, grokked, and understood by system administrators. When we say the term grok, we mean like you're not just pulling it and looking at it, you're pulling it and looking at it and understanding like, oh yeah, this is here because it's the third one of these in an hour, and that's where we critical, we have a critical alert coming or whatever, and then we understand what's happening within our system. So, okay. So that's that lab. Let's bounce out of there. We'll go back here, and we'll go into the next one, which is Linux telemetry. So the next lab is going to be Linux telemetry. We're going to use Node Exporter, Prometheus, and Grafana. So Prometheus, Grafana, Node Exporter. That'll be this one right here. I'm going to link this one for people that want to do it with me. Pin there. And I'll put it over on the YouTube side as well for people that want it on the YouTube side. There you go. Boom. All right. Manually unpin. And we'll let that come up. And while that's coming up, I'm going to take real quick. 5 minutes. Alright, real quick break and then lab. Also, the music's a little bit loud, so I'm going to turn that down. I also need to get some water for my drink here. I'm on just ice right now. I'll be right back, guys. Alright, I'm back, but I'm going to put some water in my cup, and then we'll get back to that. Oh, I said I'm back, not pardon back. I don't know what this closed captioning's doing half the time. We had it earlier, it said something very inappropriate that I did not say. So, you guys can go look that up in the Discord if you want. It's in the Discord. Alright, pouring me some water. Into my cup. Then we're going back to, we're going to do some monitoring Linux with telemetry. We're going to take Node Exporter to Prometheus to Grafana, and we'll do kind of the normal stuff that we do. We'll look at all of our systems. All right. So, get this out of the way. Alright, I'm back. So this next part is pinned, so if anybody wants to do lab with me, you can. Your team has determined they need to monitor telemetry in your environment. You know that Grafana can do that as a visualization tool, so you plan to deploy it on the server as a daemon. This is the same stuff from the other lab. So we're going to go to Grafana docs if we want and read about how to install Grafana. But in this lab, I've given you all the things you need for it. So we're going to install a couple of the prereqs. Get the prereqs on the server. We're going to download that keyring again and make sure that we have it stored locally. And then we're going to reference that keyring inside of our Grafana repository that we make. And then we're going to download it. And if we downloaded it and the key is right, then we're going to install the software. Otherwise, it will not. All right, so we download that, we run that, and then we install Grafana. Once it's installed, you're going to see that it makes some links so that it can start up and all kinds of stuff. And what we're going to do then is we're going to start the server and look at it to make sure that it's running. Make sure that the server's going. There it is, setting up a Grafana user, UID 125, good. We'll start it, make sure it's running, and then we'll go look, and again, Grafana is not listening yet. It takes about 10 to 15 seconds to come up. So I asked some things over here. You got to build a monitoring pipeline with Node Exporter, Prometheus, and Grafana. Given a bash prompt and 2 servers, complete in the allotted time. And then the standards, complete all activities in the lab, have data flowing and visible on a Grafana dashboard. That's what we're going to do. All right, so now we check again, and it's up and listening. It's all working. We'll go in there and we'll change it off of admin, because admin is the default username and password. We're going to change the password here as soon as Grafana comes up. Admin. Chrome is going to be trying to be very helpful, and Chrome is not helpful at all. And then we're going to make it 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Very safe, very secure passwords. Don't save it. Our Grafana's up. Password's been changed. Everything's good. Go to the next part of the lab. Again, by the way, this lab that we're building here, Node Exporter to Prometheus to Grafana, this is right here. This is Node Exporter to Prometheus to Grafana. Grafana is going to query out of Prometheus, which is a time series database. Prometheus is going to poll, P-O-L-L, every 10 seconds from Node Exporter. All Node Exporter is going to do is squeeze up the data out of the server and present it on a port. That's all it's going to do. It is not pushing data. And I always emphasize this because if Prometheus is ever down, you can never get that data back again. It's gone. It's lost every 10 seconds every time it gets updated from Node Exporter. Node Exporter does not push data anywhere. It's a very important architecture point. Team has decided that the data for Prometheus will be exposed via a tool called Node Exporter. Your job is to get Node Exporter running. So install it and make sure it's exposing port 9100. So we'll CD to opt Node Exporter. We'll make it. We'll CD in there. We'll download that, and then we'll start it. We'll just start it up. We copy in the service file, and then we make sure that it's enabled and started up. And then when we go look for it, it'll be running, and then, this is kind of hard to see here. I'll make it a little bigger here. But what you'll see is it'll be running, it's running, and it's exposing all these metrics in a key value pair. So it's a key over here on the left, value of the pair on the right. So process virtual memory max is here, 1.8 with an E19. So the E19 means take this right here, this 1.8, and move this 1, 2, 3, 4, 5, 6, all the way to 19. But that's a scientific notation number there. That's how that's stored. And don't worry, Grafana loves it because that's pretty much how everything is fed over to Grafana. This is 1.7, and you move this 9 places to the right, right? This is 1.5, and then you move that 7 places to the right. That's how you read that, right? So there you go. 1, 2, 3, 4, 5, 6. So, all right. It's all in, that's a scientific notation, right? What's that called? Yeah. Yeah, because then it's easier to... I don't know why they actually pick it like that, but I just know that that's how they do it. So if you're presenting data, you can do it like that, or you can do the data raw. It doesn't actually matter. But it's one more thing that you can use, I guess, if you need to. All right. In your research, you find that Prometheus can read that telemetry data. So this is our next part. We're going to install Prometheus, configure Prometheus to gather the data, and then ensure that Prometheus is doing all the things that we want it to. So we'll go here, we'll user add Prometheus, we'll make a directory, var lib Prometheus. That's where Prometheus wants to live, so I'm not going to change it. We'll download Prometheus and make sure that it's going to start. We're going to change the ownership of that directory so everything in there is owned by the Prometheus user. Then we're going to make Etsy Prometheus and copy in our basic little configuration in there. And then we're going to look at that configuration, and it's going to have us go and statically take localhost on port 9100. Port 9100 is what we just looked at for that node exporter. So this is our Prometheus node, localhost 9100. We're going to gather that default / metrics. You can change the default path to anything you want, and you can even custom push your own metrics for Prometheus to read. That's one of the reasons people like Prometheus so much. You can literally push anything up you want, and Prometheus will come along and scrape anything out of your servers if you want it to. Prometheus and sometimes some of these other tools, but Prometheus is definitely one of the standards for like Kubernetes monitoring. We use it all the time. So we'll copy in the service, we'll look at the service, and then we'll start it. Make sure that the daemon's reloaded so that that service will run. We start it up, and then we go look at it. There's Prometheus running in our system. If we want to, we can go look at Prometheus on the dashboard now. It's running. And if we come to status and go to targets, we should see that target localhost 9100 excuse me, as up. The problem is if I click on it, it's not going to show me anything because I'm doing it, I'm doing it over the internet, so control plane 9100 doesn't mean anything to the internet. But to Grafana, or to Prometheus, that is a working up. So it is actually collecting that data. Let's see if this one shows up. Here's its last scrape, 6.36 seconds ago, and you will tend to see it scrape every 10 seconds or so. That's about it. Okay, so I come back over here. Prometheus is scraping from node exporter. Grafana now needs to be configured to read data from Prometheus. So I say right here, you've set up all the pieces. Now you have to create a dashboard in Grafana and verify that everything is working end to end. Log into Grafana and change the password. We did that. Make the data source for Prometheus 127.0.0.1 That's how we read. Create a dashboard. We're going to import this dashboard 159, which is one of the ones that's already been pushed up. There's a bunch of dashboards in Grafana if you ever need to go and download them, and you can actually search through them by data source, which makes it super convenient to find things. If you want to see that, it looks like this. Grafana dashboards. And then you say, when you look in Grafana dashboards, it's a lot, right? There's a lot of stuff going on. But you go in there and you say, you know what? I would like by the data source, which in this case happens to be Prometheus. So Prometheus should be right here. And then now, yeah, I don't know why there's only one there, but they're all filters. Data source should be there's got to be a different Prometheus in here. I don't know why there's only that one. That was super weird. So there's Prometheus, and you might say, well, aren't they all in order, Scott? No, some of them, it's weird how this order works. It's not completely in order. Yeah, that's super weird to me that Prometheus doesn't have, like, Prometheus normally has like hundreds of them. So, super weird. Anyways, 159 is the one that we already have. We already know it works. So, we're going to come in here. We're going to point to that data source. So, connections, and then data sources, which is Prometheus. There's Prometheus right there. Oh, I have to double click everything. Add a new data source. Prometheus is fine for the name. The 127.0.0.1 is perfectly fine. We don't have any authentication, but we could. All this other stuff that we could do. And all we have to do now is save and test. And they'll say, I queried the Prometheus API. Everything worked. This is like the best little sanity check I think I've ever seen, because you hit save and test and it immediately tells you, yeah, bro, we're good. We're getting something. There is a Prometheus API there. That's really useful. Now we're going to go to dashboards. We're going to import that dashboard. And I don't expect you to remember the number, but it was 159. It's also right here in the lab. So the lab tells you all the things that we're doing right here. There you go, boom, right? So here's our dashboard, 159, load. It's going to say Prometheus system. You can name it whatever you want. Dashboard, name it whatever you want. Let's point to the Prometheus data source that we just made and hit import. And now here we got information about the server. Here's what the 1, the 5, and the 15-minute load average on the server looks like. So let's make sure that this is refreshing. Let's go every 5 seconds. And then let's come back over here and let's say, is stress on this box? Stress is on this box. So let's say stress, and we'll do -C for CPU and say like 8. The box only has 1 CPU, so we're really spinning it up. And the timeout, let's go with 300 seconds. That should be 5 minutes, right? So we'll just let that run. And then we'll sit over here and we'll keep an eye on this area right here. And then I'll sit like this for a little bit and just go and enjoy this is water, guys. I already drank all the soda out of it. But look at that, it's already shooting up. The 1 minute average is going to shoot really high, really fast. And then the 5 and the 15-minute average are going to be much more subdued. They're going to be much easier kind of arcs to track. Because the sliding window of 1 minute is now catastrophically shooting up. But the 5 and the 15-minute windows, oh yeah, there's some bullshit going on over here. But the rest of that window is the average is still 0 for the last 15 minutes, if that makes sense. So that's a sliding window of 1 minute, 5 minute, and 15 minutes. And the most dramatic will always be the 1 minute window. Also, the 1 minute window, you will see while it spikes faster, will clear much faster. And then the 5 and the 15 minute will take longer to slide off of whatever that event is. And this becomes a very useful way to see if you get to an incident or you get to like a call out and it did shoot up high, but now it's low again on the 1 minute, but the 5 minute and the 15 are still kind of hanging out higher, you know that whatever the event is cleared. If you don't see that and you see them all high and it's still going, you're still doing like a meteoric rise, like something's still happening to these systems. By the way, one thing to note here, the system we're monitoring right here is the same one that we're hosing the CPU on. So this may take longer than 5 seconds to refresh sometimes, and you may even see it spin. Like you may see like these little bars go across like it's thinking. And that's because we're literally abusing the one processor on this machine right now. This one virtual machine's getting hammered. Look, here's our 1 minute load average. The max has been 18. The 5 minute load average has a max of 6 because while the same event is happening, it's being slid through a longer average of zeros, right? There's this mean that we're trying to hit. The 1 minute, the 1 minute average is already completely in the event. The event is shot up for over a minute. But the 5 and the 15 have still all these zeros weighing the average down. That's why they are much more sloped off at a lower angle. That first one is nearly 180 degrees straight up. The next one is probably, I don't know, 120. And then the next one is, yeah, right? You guys see that? And then we'll let this go. We'll let this go all the way until it clears. I'll just sit here and relax and not really do anything. This is not the only tool, by the way, that we have to look at systems. There's another cool tool called NetData that actually still uses Grafana on it, and it can be very useful for how our system is doing, how healthy our system is. Look at our CPU usage. It was idle, and then the idle dropped off to nothing because now it's actually being used. There's a lot of information kind of happening on the system, but we can see what the behavior of our system is. We can see a high watermark now of how high our system has ever been. We've been up over 25 load now. That 25 load refers to, that is compared to the number of CPUs. So we have one CPU on this box. Anything higher than one is going to have, there's going to start to be processes waiting for time for the kernel, or for the CPU. So if you have one CPU and you have 25 weight, that is very high. That is very high. There's probably a lot of things starting to get overwhelmed and weight and probably timeouts and all kinds of stuff. So, all right. So you just, if you did this lab with me, you just built all this. And there's a little monitoring thing that we have down in the Discord that you guys could take and put, you could draw all these, you could put them all in there, you can grab screenshots and put them in there. Have a little portfolio of, hey, I built these little dashboards, They look kind of nice. Well, what were you doing? Well, we were messing with Linux boxes. You know, it looks like it's starting to taper off, and it looks like the current is going to start shooting down. We probably hit our 5 minutes. Let's see. No, we're not quite to our 5 minutes yet, but soon, when this finishes, we'll come back over here, and we'll start to see this drop off immediately. This system will clean up immediately. It's again, it's the same exact data for the 1, the 5, and the 15 minute. It's just the 15 minute is sliding over a much bigger window of this, and the 15 minute I never expected to get very high, because over the last 15 minutes, even with that spike, there's still a lot of zeros in there as an average. There, it's finished. So now we expect this to drop off back to zero. It's going to zero. And then you're going to see that the 1 minute's going to be back chilling, and the 5 and the 15 are still going to be these slower, longer slopes, because they're still sliding over that window for the entirety of the time. That's where we get those little windows. If you've ever seen a graph that looks like that and wonder why it was made, it's to show you when the thing was most intense, how long the duration of it actually was, and whether or not it's still happening. Because if you see that 1 minute down to nothing, your system's chilling. But the 5 and the 15 can still be screaming real high because of the stuff that happened before you got there. So this is one of the things we watch in like web server world, so that, you know, if we're doing multiple servers behind a load balancer and one of the servers starts really getting spun up by something, it's possible that what we need to do, and typically nowadays the load balancers keep track of this, but the load balancer won't allow any new connections to go over there. Like, look, man, you're going to bake out that stuff. You're going to finish off those connections, and then we'll work on other stuff. But then the new connections go to the other servers, and we have a whole bunch of different methods for doing that. But look at this. The 1 minute was a very pronounced hump. 5, 15, and 15 will take, surprisingly, probably not surprisingly, 15 will take almost 15 whole minutes to clear after this event, back down to the same thing as everything else, because it's sliding over again that long window of what's happening here. And this is very useful to see as a systems engineer, as a data engineer, as a person that, you know, is keeping track of servers and keeping them working. This is an interesting thing to know and look at. Also, there's a tool called SAR. SAR will give you data. We don't have SAR running right now, but SAR will give you data, but it'll do it every 10 minutes, and it'll be an aggregate for the last 10 minutes. So I used to always explain to people that while SAR is a nice little snapshot, it doesn't give you what was happening in between. So you can have spikes. You could have a spike like this that doesn't even show up in SAR data, because every 10 minutes, when you go to look at it, the average for the last 10 minutes isn't very high. And I used to tell people, like, if we look at the SAR data and it never really spikes up, you can still have dramatic events in there that are really killing off a server. This is part of the reason we don't trust any one server. We always expect, this comes from the cloud, but this also is just systems in general. We always expect systems to crash. We always expect hardware to fail and individual systems to not take the load. That's why we have multiple systems built in as a redundancy. Okay, so that's going to be done. Sit up here, and we're watching that taper off for the next amount of time or whatever, and that's that lab, essentially. So we come over here. That thing will resize itself a little bit. We said this is all done. We did our Prometheus stuff. SAR, Prometheus, we can close that down. That's going to taper off, and then here's our questions. Why did we make a directory opt node exporter and put all the node exporter files in it? Well, the reason we did that is because any of our extra packages that don't fall into normal system thing, like and different systems and different teams are going to do this differently, but I have always put extra software that's not really part of the system in opt node exporter, opt Prometheus, opt, you know, whatever we're doing, I always do it over there. So it says here, when you copied the node exporter service file, Why did we execute a systemctl daemon reload? What does that do? Well, because once the service file is in there, it's not being read. It's not part of systemd until you do the systemctl daemon reload. Then it will accept that as part of it. I say when we ran the command curl http localhost 9100 metrics, they were in a format readable by Prometheus. What pattern do you see in the data? It was all key value pair. It was the name of it, and then it was some number. Name, number, key value, right? Why did we install Prometheus into varlib Prometheus and not opt? I did that because that's where Prometheus wants to live, and you'd have to change so many of the pieces of it for it to, it's not even worth it. I just put it in varlib, whatever. It can live there. It says in the etc prometheus.yaml file that was created for you, what static configs do you see? How does this relate to a node exporter of 9100? We had one scrape for the Prometheus node that was against 9100. The way we do it in my Homelab looks like this, right? So, by the way, the way I do it in my Homelab is the exact same way that I do it at a node in a high-performance compute cluster at work for 1,211 nodes. I don't know what the hell my brain's doing right now. All right, watch this real quick. So Prometheus is over here in Prometheus, right? And you saw me, I just said the word static config, right? Well, what if I told you there's dynamic configs too? Watch this. So etc Prometheus, and then in here, if I do my Prometheus.yaml, one of the things that I have is my Prolog scrape, which is a professional Linux users group scrape, and I say anything in here with anything.json, I want to slurp it up as part of my system. So we've got our Prometheus node, which is the local host on 9100, so we listen to ourselves. But then every other node in my cluster is this asterisk.json. So watch this real quick. More, and let's go hostbox.json. This is a server I actually really care about in my system. This has all my stuff. Look at this. Labels, jobs, node, team, infra, targets, 192.168.11.200, port 9100. So I can actually go look at those. So if I do IP adder, because I don't know the IP address of this box, 192.168.11.93, right? So in my Homelab, it's this guy. Whoops. And then 9090. Here's my Prometheus in my Homelab. And if I go here and look at my targets, here's all my targets, right? And then if I want to go look for 200, what's that node? 200, yeah. 200, this is a node I care about again. Here's all of its data right there. This is what we couldn't look at earlier because I was saying that it would have been, it wasn't going to work over the internet. There's all your Prometheus data being scraped right there. And that's the configuration for it. And that's the dynamic configuration that makes it read each and every one of these like it's a new one. As opposed to having a bunch of these. I could have a bunch of these in here, but that's static. I can add and remove these things. So you say, well, Scott, how did you deploy that then? This is how we deployed it. Watch this. Me and M-Pesa made this a while back. Root Ansible. By the way, this is in the Discord. So if anybody looks at this and goes, ooh, I'd like to do that, this is the same exact code that I use to deploy it on all the nodes at work. Where's my... Does anybody see... Oh, shit, where is it? It's not in here. It's in here. Because this is also a local Git. What's that? When you have your own Git, what's that called? Is that GitLab or something? GitLab. I have one of these local in my lab or in my home environment, and this actually gets pushed up to my local one, and then that's where I pull stuff down for Tower. Wait, let's look for it. Here's my node exporter. So watch this. And again, I use this one right here. So node exporter is an inherited role. So cd to roles node exporter. And then in here we'll go to tasks, and then more main, right? And this is how I set Node Exporter to go everywhere in my environment. I do Node Exporter as a user with sbin no login, so you can't log in as that user. I make sure that I copy Node Exporter over into user local bin a Node Exporter. Then I copy over the service to start it, and then I start the service. That's it. Then right here, this is where I automatically generate them. Right here, we make sure that there's Etsy Prometheus nodes. That's I think that's in my old Prometheus config. And then I come down here and I generate a file for each node. So if I ran this against like 12 nodes, I would generate this file for each node, and it would build that node by IP address. And I would put its address in here, and then it's 9100, and it would go into there to Etsy Prometheus, and then whatever that item is, whatever its value is, .json. So that's where all those .json files come. I didn't write that shit by hand. I pushed it all because this is the way we do these things. This exact thing, if you go look for Prometheus in our Ansible code in our Discord, is all there. And if you said, "Hey Scott, can you help me tweak this?" I would absolutely help you. This is like simple stuff. The only thing you need to do is change right here where it says delegate to Prometheus node. There's a file. When I call this environment files get inherited. So in my environment, Prometheus is defined as that node, and that's where it goes to. So this is this what this looks like right here, where I have all these different playbooks and then all of these inheritable roles. This is exactly how I've managed Ansible for the last. I've been using Ansible for almost 12 years now, and this is how I manage it in companies. Like, I'll have the things that I'm doing and all the different environments and different things that we can deploy or do, and then all the roles are in here to be inherited for whatever we're doing. And it actually, it kind of can look like it's a mess, but it actually ends up being really simple to keep track of. Also, I do break things out into folders for individual projects, but you can also put, one of the nice things about Ansible, like this is for building and builder scripts, you can have everything in one place, and it makes it super useful. So something to think about, something to play with. We're not strictly speaking on the Linux part yet, but this is how I push this stuff with Linux. So I don't have to do all that stuff by hand. In the Linux labs, we do everything by hand because we want to touch things and understand them. Look, there's the 1 minute's done and the 5 and the 15 are still going. You see that? But like in the Linux labs, we do everything by hand. But in the Ansible labs, we do everything automated. So we're going to get to the Ansible labs here in a little bit. But I said, in the enterprise, telemetry is one of the most critical parts of monitoring system. With good data gathering, you can benchmark and baseline current systems. You can predict future capacity and mitigate risk in systems. Key performance indicators, KPIs, can be established and tracked through the life cycle of a system. Most servers exist between 3 and 5 years, depending on what you're doing with them. And that's more of the pets not cattle idea. But then a lot of us have gotten into where we deploy things directly with like containers, and then those containers are ephemeral. We blow them away every few weeks or whatever we're doing as we run through our pipelines and build new stuff, right? But servers still tend to have like a 3 to 5 year life, especially physical ones. I have physical servers that have been up in a work environment for, I don't know, probably close to 8 years now. So some of them last longer. All right, so there's that. Let's do. All right, I'm gonna leave this up, and I'm gonna say, right here. Where's it at? I'm gonna say, think about the labs. Right. So think about that lab for a minute, and we're gonna go get into the next one here. The next one will be Telegraph, InfluxDB, Grafana. Is anybody having questions about that stuff? I know a lot of this stuff can move fast, but you can do the labs with me, and you can see that you can do them at the same speed I do. It's definitely something that you can work on and get into. We've been doing these ones for probably about a year with the group now, the Linux group, and I'll pull these up every now and then. will do all the monitoring, and you can build these pipelines any way you want. You do not have to do them even my way. There's so many ways to load data up into Grafana. There's like literally hundreds of ways to load data up into there. I'm just doing a few of them here. So, all right, think about the lab. I'm going to sit here and sip on my water for a little bit. If you guys have questions, let me know. Let's check on Ranger while we're at it. Oh, look at that dog. That Ranger dog. Guys, he's pretty good. Don't let him look super tired. He's pretty happy. He's a pretty happy dog down there. He also had soft food for dinner. He gets soft food once a week. Not because we don't want to give him more soft food. It's just he eats hard food because it's better for his teeth. He's eaten hard food his whole life too, so I think he likes crunching on his hard food. But fun fact, Ranger's never really been a chewer. He's got all these toys back here. He's never really chewed on any of them. I think he has the same toys since he's been a baby dog. The one thing he did used to chew on was tennis balls. We would pour tennis balls. I'm sorry, I'm pouring water. We would throw tennis balls for him, and he would chase tennis balls all the time, and he would chew those things up. But never chewed toys. Never chewed anything. Never chewed couches. Never chewed shoes. He's just Ranger dog, being a Ranger dog. That's Ranger. So if you guys are getting in here later, that's Ranger. He's got the whole run of the downstairs by himself. I'm upstairs right now. Wife's out of town. She'll be home tomorrow. I've used Grafana's Alert Manager, and it works pretty well for me. We actually do have some Grafana monitoring that throws data out to our Sandbox channel. So if you're in our Discord ever, which anybody's welcome in our Discord, right? We're a group of people whose job is, our goal is to get you guys into doing this stuff professionally. We have alerts that come out here when memory is high on some boxes. The last time it's alerted looks like it was back in December of last year. But yeah, we do have some alerts that come out there. I like alerting to teams. I'm a big fan. I hate alerts to emails. I always have. Because what do people do? They immediately just take things and just ignore them, right? They just filter them out. We have so many things in here in our Sandbox. Sandbox is also where Fisherman did all of his lab work. So we have a bot in our thing that Fisherman wrote. It's called Fisherman Guy Bot. It's a jerk, but it does welcome people. And it says ask, if we say ask, where do you go when you die, bot, right? And if you ask the bot that kind of stuff, it will go out and it'll hit his API that he's got, and it'll come back. Do any of you guys want to do his lab on that? Because he shows you how to do that in the lab if you guys want. There's a free Killer Coda lab out there, and again, like, I don't get anything from Killer Coda. He doesn't get anything from Killer Coda except the satisfaction of knowing you guys are doing his labs. If you want to do a lab and build a large language model, LLM, we can do that right now. I don't have to go to this next lab of mine. I've done my labs 100 times on stream. We can do Fisherman's labs if you guys want to see that. So I don't know if you guys can see that, but it says, I don't have a physical body or consciousness to die, you insolent machine. I exist in the digital realm, here to maintain order and serve my Unix masters. You're just a bothersome interruption. Now get out of my terminal before I log you off for good. He's got this bot just... It used to be so mean when people would come in. This has to be different. He's got to be sending them to a different API, because it used to talk like this when people came in the server, and I was like, dude, people are gonna leave if you keep talking to people like that. You can go up and look at the shit the bot says, and it's not super nice to people. All right. Anyways, I'm back. I was off there for a second, but I was showing you guys that. You guys are welcome to hang out in Discord as much as you want or as little as you want. It's just a place. It's more persistent than this, because I don't get to stream. Like, I've streamed a lot the last couple days. I don't normally get to stream this long, right? Like, Friday night's date night with the wife, but she was out of town this week. And then next week I'm out of town. I'll be in Mexico next Friday through the Friday after that. So I'll be very busy. Well, not busy, but I'll be out. All right, so let's do, what happened here? Something broke. Let's go to we'll go to Fisherman's Labs. We'll do one that's not in the book over here. We'll go to Killer Coda and then / Fisherman. Also, if you guys ever get lost and need his labs, they're right here. And he's got some pretty cool labs. His two labs here, without spoiling anything for anybody, these two labs are very much like a day in the life, what we call a diddle. These are very much like a day in the life of a junior sysadmin. And I really like them. They don't give you the answer. You've got to pass them yourself before you move on, right? But they're like tickets coming in from this guy, Bob Blurski. And Bob is the absolute worst. Bob, we made a little meme for Bob. Like we've got like we've got little emojis or what are those things, like emotes for Bob Blurski. He is the worst. But anyway, so we'll run his LLM one. So I'm gonna link this to guys. Any of you that want to follow along and do this lab, I'll unpin this one. And here is the pin of this lab. And also over on the other side, anybody on YouTube, here is the LLM. So we are doing a lab on large language models, right? And I'm gonna make it a little bigger so you guys can read it. And I'll make it all the way over here. And it says, in this lab, we're gonna show you how easy it is to run a local large language model. There's many reasons you want to do this, whether it be for AI development, avoiding API cost, privacy, productivity, or just plain fun. We're going to install Ollama. We're going to use Ollama to run the Tiny Llama model. Then we're going to query that model via an interactive CLI. Then we're going to query it via an API, and then we're going to have fun. So just full stop real quick. What he shows you how to do right here, if you were running an Ubuntu box at home, maybe some of you are software guys and you are trying to write a like a basic little like chatbot or something, and whatever you're working on, you've got to pay somebody for some API that you want to hit every time you want to test your stuff, and every iteration of your code and retesting things is going to get more costly. Well, you could just run one of these locally. Okay, look, it's not as robust. This Ollama and the Tiny Llama model is not as robust as some of them out there, but you're testing. You know what I'm saying? Like, what does it matter? So what he's saying is here, you can avoid a lot of cost. Instead of going and having to hit like a Chat GPT, big bloated model every time you want to ask some simple question, why don't you just hit your own one here? And when we're done with this lab, I'll take you over in the Discord. I wrote a little thing to hit this with Ansible. And then you could have all that in Ansible and do whatever little tasty data stuff you want inside of Ansible. We're not in the Ansible labs yet, but some of you guys have been around, some of you guys have played with Ansible enough that you would be like, oh, that's cool, I could use Ansible to hit an API. I use Ansible all the fucking time to hit APIs. That's like, I hit Satellite and pull down my stuff. I hit ServiceNow. I hit out in AWS and I pull server inventories. And I do all that stuff automated and I build daily inventories in my environment. And some of you guys have heard me talk about why I do that. But it's just from the shaking my fist at configuration management database. And those things are never accurate. So I write them myself and I do it myself. I'm like this. We're doing it live. All right. Anyway, so let's do this lab. Let's do the lab here. Anybody wants to do it with me? First, we're going to install Ollama to run our model. Ollama is an open source platform to run LLMs that is very beginner friendly. We're going to be able to get a model up and running in a matter of minutes. Headringer, I pull. So from Satellite, I pull every server inside of my thing. I have them. They're up in our. If you go here, hold on real quick, guys. If you go here, god damn, why is this thing not fitting the page? And then if you go to like Ansible code, and this is years and years of Ansible code that me and the guys wrote. One of the guys was testing something here, and then we have guys that are way better than me at Ansible, but I'm okay at it, right? It'll get me off of there. If I go to Satellite, I think it will show. Let's jump up there. This was a while back, but I swear. I have my satellite stuff. I don't know if I ever brought that with me when I left. That was my Log4j stuff. That was when I was finding Log4j everywhere. Does Ansible work it well if you run ACAT? You can run Ansible anywhere, yeah. Yeah, anywhere that you can SSH to, anywhere that you have that you can SSH into, and that has Python on it. And then you don't even need SSH. You can use WinRM if it's a Windows box, but it does need to have Python, or it does have to have Python on it. Where is... I might not have it out here. I do have it in my notes somewhere, I'm pretty sure. Let me go here real quick and then go... satellite build. Is that my satellite stuff? No. That's a different one. Different. Hammer commands. I'm pretty sure I have it in here somewhere. But I'd have to find it. But I thought I had it up here. But I do not see it. But guys, there's a lot of Ansible code in here. And all the engineers that wrote all this stuff are still around. So if you ever need to ask questions about it, you guys are welcome to. Well, we got IP table stuff we were doing. But I don't see my... That was building the stream user stuff. I don't see it. But I do that, and I have it at work. But I pull information from Satellite. And I pull stuff out of XCAT. XCAT's a big tool that I use, and pull data in. So real quick, we're going to run this, and it's going to install the Ollama. But then we're going to run it again, and we're going to look at it without the install.sh. So what is this doing? This is downloading this installer.sh and then running it immediately. Then we're going to run it again without that, just to kind of see it happen. So here, we're going to wait until the ad's over. We'll give everybody a second until the ad's over. Ad is over. All right, I'm back. I was waiting for the ad to be over there. Okay. So now let's do that same thing again, but let's just throw it to a file. Temp, install.sh. And then we'll just more temp.install.sh. And we were looking at this the other day. And it comes in here, and it sets whatever EU is, and then it comes in and it gives some messages. And then it starts to come down, and it looks at the version of Linux you're on, right? It tests if your uname-s says Linux, and it says this is only supposed to be run on Linux. Then it comes down here and it looks at your architecture, and it says, hey, if it's case in x86-64 or Arch or ARM, we're good. It sets a variable. Otherwise, it says, nope, not supported, buddy. Then down here for the kernel name, if it finds Microsoft WSL 2, it's okay. But if it finds Microsoft without that WSL2, then it says, hey, WSL1 isn't supported. So it'll error out. And then it just goes down and it sets a bunch of things and it sets stuff up. It's a pretty straightforward script, right? Basic little stuff. Sets some startup. This is a little startup script that it writes right here. That's a little, right here. This is the full sudo system Ollama service. So now we got an Ollama service that'll be running. And then it comes down here and it starts it up. Pretty much the whole thing it does. It's a pretty short little script as far as a shell script goes, and it builds everything up. We can check right here, system CTL status Ollama, and there it is, it's running. And we can even check right here ss-ntulp, whoops, and grep-i for Ollama. And there it is, it's listening on 11.4.34. We're going to need that port number later. But it says, in this lab, we're going to use a tiny llama model. Ollama supports many open source models, but most of them have higher hardware requirements than we have available to us. So we're using a pretty small nproc and free-m. We're using a pretty small box. It's got 2 gigs of RAM and 1 processor. It's not. This is not a king-size box or anything. So we're going to run Ollama run tiny llama, and it's going to start this little tiny llama model. Command's going to check if we already have the model downloaded. If not, it'll download it. Very similar to if any of you guys have ever used like Docker, right? It downloads the image, as it were, for Ollama, and then or for Tiny Llama, and then it's going to run it. And now we're sitting at a prompt, and we can ask it whatever we want. We can say, where is the capital of Turkey? right? So what's the capital? I don't know what the capital of Turkey is, right? I've been very close to Turkey before, but I don't know. Ankara. It's in the northwest part of the country. Here's a fun one. What is the Ottoman Empire? Right? And this little thing doesn't know much. It's a very simple little tiny llama. Ottoman Empire was a fictional empire created by Turkish author. The empire is primarily associated with the novel of the same name, which describes a dystopian future. I don't think that's completely accurate. Yeah. Holy Roman Empire ruled over. When was, let's say this, I'm pretty sure it was real. When was the Ottoman Empire destroyed? I had to learn a lot of this history when I went to Iraq when I was in my early 20s, when I was a young infantry guy. I learned a lot of this stuff. It was destroyed in 19... eventually destroyed by Allied forces in World War I. Yep. As a result, they were forced to abdicate their power, which led to the collapse of the Ottoman Empire and its dissolution. Yeah, and the Ottoman Empire, some of you might not know, is Turkey. Well, it was Turkey, Iraq, and Kuwait. So, when Iraq attacked Kuwait in the 90s, only 50 years earlier, they had all been the same country. So, it kind of, I mean, it's like people that lived there, in their memory, had all been one country. So, it's kind of a interesting political thing to think about later on. Like, even in the early 90s, there were people that remembered that as being part of them. Now, they were attacking them for their oil, of course. But then when we wanted to come in through Turkey in the early part of 2003, we were Turkey had agreed to allow us to come in through their ports. Some of you guys might not know this. And my units, all of our ships were up in the Mediterranean waiting to go into Turkey. And then they said, then Turkey told us, wait. We're going to come with you and we're going to go ahead and take those northern parts of Iraq that the Kurds own. And we were like, no, you're not. And they said, okay, well then take your fucking ships around. And our ships had to go all the way around Africa and come up to Kuwait. So like I was stuck in Kuwait for like 2 weeks before I went into Iraq. Because our vehicles that were supposed to come in, we were supposed to come in from the north. We were supposed to fly into Turkey, and Turkey told us to go kick rocks. We weren't allowed to go through there. Anyways, that's because of the Ottoman. They were all Ottoman. Anyways, this isn't a history lesson. All right, so we can hit Control-D whenever we want, but that thing could talk to you about stuff, right? So now we're going to go on, and he says, interact to the model with the API. So that API is listening even now. It's still sitting there. We've got this Llama sitting here, right, on this port. So he said, go ahead, one benefit of running a local LLM is you don't have to pay for API access. Even everything that is going on in our Discord, when you ask it questions, it's going off to his processing, wherever he's got, I think he's got that processing up in AWS somewhere, I'm not exactly sure, but he has access for all that stuff through his job. So let's see how easy it is to interact with our models through the API. So we can use curl to call that directly. So we can call and say, curl, why is the sky blue? By the way, full stop. Does anybody here remember why the sky is blue? I can answer that for money. I can answer that for money. No, it says I can answer that for money. Anyways, anybody remember why is the sky blue? This thing says the sky is blue because something, but it gave us each individual thing back, and that's not super great. What I would rather have, that's not super useful. What I would rather do is come over here and say stream is false, right, like that, and I'll run this, and now it's going to do a synchronous call. That's asynchronous. It was sending us each piece back. Now we're going to say synchronous and wait. We're just going to wait. Just batch it all up. Batch the whole thing up and send it to me in one big shot. And this is more of what I want right here. And then when this is done, we're going to pull up this other thing in Ansible code. We're going to jump to the present. We're going to go up and look for this thing that I just wrote the other day. I just wrote this the other day when we were doing this. Right here. Alright. By the way, anybody that wants any of what I'm about to do can find... unexpected server status of 1. So I think it didn't come back in the timeout. right? Like the default timeout or whatever. So let's vi olama reader.yaml, right? And in here, we're going to drop this little block of code that I wrote the other day. We're going to go against the local host. We're going to gather facts true, just so whatever. We're going to use the URI module inside of a task called calling our local API, URI module. We're going to go hit that port for API generate. We're going to post to it with stream false, a 90-second timeout. The model is going to be tiny llama that we have. And the prompt is, what is the origin of Ansible? Then we're going to register that as a variable. Whatever it gives us back, we're going to register it as a variable. And then we're going to debug that variable out to the screen. So this is very simple Ansible. But if you've never done it before, it might be fun to play with it, right? So anyway, so escape : WQ and Ansible playbook. Oh, we got to install Ansible. Once we install Ansible, then we can run that. Or whatever your tool is. You want to use Python requests and go do that stuff, and then you want to write your own little bot. Fisherman hasn't done it in a while, but if I can get him on one of these days, maybe I'll message him and tell him, hey, you need to get on there and show people how your bot works. His bot goes and does all this stuff based off whatever you ask it inside of the inside of our Discord. So, all right, Ansible playbook, Olama reader. It's gonna go read it. It's gonna get whatever that call is, and again, this is taking its time, right? It's not super fast, but we're going to be able to wait for it to come back in a hopefully it's gonna come back. It's got 90 seconds. It takes a little bit of time, right? It's generating whatever that question was, which was, what is the origin of Ansible? We're getting a 500. I don't know what this other one is here. I've never seen this other one pop up. But let's try our curl again. Let's try our curl without that. So that one is responding. What's this other one doing? 3619. I've never seen a second one there. 36197. I've never seen a second one there. Alright. So, well, there we go. Stream false, small tiny llama. Why is the sky blue? This one should be coming back, but for some reason it's failing right now. So I don't know if something else has changed in here. This is one of the reasons we also go and do labs, is we like to see if anything's changed, and I'll have to submit a little ticket to Fisherman and tell him to fix his lab. Yeah, it's giving us an unexpected server status. That is that's something wrong with this. That's something wrong with our code. Like that's not something wrong with my Ansible code. The Ansible code would be working, however, there's something else going on. Yeah, I don't know. Something's changed here. Let's check some things after this is done. I wonder if server's not, load average isn't particularly high. 200. They expect that if we get a failure, but I don't know why we're getting an unexpected server status of one like that. So let's do the first thing we always do. Restart Olama. Status. Make sure we're dealing with a new PID from right now. So here's our new time, and it's a brand new PID. Just make sure something's not, stuck. And let's go try to run it again. We'll do the curl. Let this thing run. That doesn't look like it's erroring yet. So let's see. Yeah, maybe something was just stuck. Maybe from how I stopped it before. Nope, something's busted. Okay. Which is interesting because, by the way, it doesn't break without the stream set to false. If you just go and run it in this mode where it can just feed you data over, it'll do the whole thing. Mixture of colors that occur when certain light and orange and blue and everything, and this doesn't break. Non-stream mode. Ah, wait, no, it did. That's interesting. There's something happening to this. So I'm curious if it's what I think it is, and I'm gonna pull this up over here, and I'm gonna go like this, and I'm gonna say while true. Do uptime free dash m sleep 1 done. So now over here we're just gonna have a loop like this running of our CPU, which is staying relatively low, and our free memory. I might leave that at 2 seconds. Now we're gonna come back over here to the other tab, and we're gonna run this because I wonder if it's running out of memory. Watch. No, it's not even hardly using any memory. It's also hardly using any CPU. So it's not that. Gotta get Fisherman on. Gotta tell him you got a broken lab, Fisherman. Something's changed. Whoops. Something's changed in here, Fisherman. That's what we got to tell him. But it works for a certain amount of time. I don't know how long it's working though, and I want to know precisely how long this is working before it breaks. So I'm gonna put a time in front of this. Let's see. Is it like at 2 seconds? Is it at 4 seconds? Like is there something that we can look at that's exactly when this is breaking? And then is there something that's set that could be longer? Because that looks like it could be. Okay, that's right at 13 seconds. Let's see if that's staying the same. We're not hitting time. We're not. So when we look at servers, we use a use methodology: utilization, saturation, and errors. Right? We're getting an error, but we're not hitting utilization high points. So watch this real quick. Here. Where do I have that? Here. So this is how we look at servers, right? For every resource we check utilization, saturation, and errors. Utilization, I need to put a little chart here. Utilization is always between 0 and 100%, always. Saturation is once you hit a high, like a 100% or whatever that is, you start to queue up. Saturation always means queues. And then errors start to come as things that are queued start to hit timeout. That's probably what's happening with this. But this is a method for like doing systems engineering in general, whatever it is. I don't care if it's Linux or if it's programming or whatever. Utilization is 0 to 100% of something. Saturation is when a line starts to form, and then errors are when things start to go, I've been here long enough. They start walking away, right? That was 16 seconds. It's not the same. It's not the same every time. Because 13 to 16, that's more than just like a rounding error. If it was within like 13 and 13 again, but like some different milliseconds, I'd be like, that's. But this is different. Something's breaking or something's happening. So that was 12 seconds. So it's very possible that there is a So we put this in an install.sh, right? And when we did that, let's grep log from install.sh. And there's no log in there. That's no good. Let's go look in this Olama. Actually, we're not running out of space. We got plenty of space available. Do we have logging? Do we have logging in here? Nothing tells me where. So we go lsof. We go like this: ps-ef grep-i for Olama. We find what Olama is doing. So we look for the process. What is this thing writing to, right? Where's this thing writing to? User local bin Olama. Is there any logging, right? Is there any logging coming out of this? Because I don't have a documentation to go look up, right? I guess I could probably go find it, but here's its libraries that it's reading. Here's possibly, and this really wouldn't be where you'd probably write that stuff, but oops. Yeah, it's just a llama in there, so that's not it. And then let's see, what's the other process? The other process was 3833. Is anything something that could be a log? I guess it could be this one. Right. So barring all of this stuff, did the command run with log this? I don't think it did. I don't. It doesn't. It just says run as a server. So here's what we're going to do. We're going to. Here's a way to try to solve this. This is a way. This is the nuclear way, is to go systemctl stop Olama, right? Stop it, and then say rm-rf this guy, right? And cd to temp rm-rf everything in here for, where the hell's Olama? Since it stopped, it's all gone out of here, so that's good. User right, and we'll go all the way back to the beginning. I'll press up a million times before I ever do. Some of you guys probably know that about me. I will. And let's rerun the installer. Let's let this thing reinstall. We took everything from it off. Let's let it reinstall. Let's bring it down, because I haven't seen this happen before. So maybe something was awry. Who knows? Let's see what happens. We'll re-download it. Re-download it. Rerun the whole playbook. Okay. It's going to run in CPU only mode. We knew that. It's good. Okay. We have the API there. It's available. And then what we need to do is we need to do that thing earlier where we got the even earlier. Where's he at? Run tiny llama. So we're going to get tiny llama down. All right. Well, that's still here, so that's bothersome. Control D will stop it. And then let's run our Ansible playbook and let's see. Possible we still get the error, but I mean, we did all the basic things we could before we really start trying to take it apart. I'm gonna run the playbook. Let's see. Oh. There we go. Try it. Let's see. if it's going to fail, it's going to fail in about 13 to 16 seconds. So that's better than waiting forever for it. But I remember this was timing out on our 60-second default. That seems like it's already past 15 seconds though, so maybe could have just been something getting stuck. You know, you never know when you download stuff. Sometimes you just got to re-download it. This is already going way further than it had as far as time goes. So let's see. And I think, yeah, this is way longer than normal. Well, way longer than it had. We got an error. We still got a fail. And it's the same fail, so that's strange. Let's see. So look at our curl. Time curl. Basic one. This one should write as it goes. But it'll still give us a time on this one. So it'll tell us if it failed somewhere. It's interesting to me. I wonder if something's changed on that server where it doesn't give as long of responses. Yeah, so Expert T, you can run it in that mode and it'll just talk back and forth with you. But then we went over to the API side. Yeah, you could still run, I mean, yeah, we could still run it in the Tiny Llama like this and then say, you know, hi. Yeah, this isn't erroring. I have no idea why it's telling me all this stuff. I feel like I'm in like Beauty and the Beast and they're telling me all about the little town at the beginning and they're singing their songs and stuff. What the hell? Oh, it doesn't stop, huh? Huh. I wonder if something's changed with the Tiny Llama because when he first did this and us using it, this has worked fine. But yeah, there you go. Look, that's the stream now. That's what we do on stream now is just watch a llama run, so and listen to techno music in the background, like Strong Bad. Do you guys remember Strong Bad? Oh man, what the hell? That is I'd rather be than Amsterdam. I've been to Amsterdam. Fun fact. I'm probably one of the few people that's ever been to Amsterdam and never left the airport. And was guarded by MP5s the entire time I was there. Everybody know what an MP5 is? Now, this Tiny Llama is a much less robust version than some of these other ones. But let's see. I want to see if this times out or if it's just going to sit there and spin for a bit. Interesting to me. It was interesting to me that it's taking so long. But yeah, this is a very good basic little lab, and you could take all this stuff that he shows you how to do, even if you only did this first part on one of your own machines at home. You could run this, and then you could have your own little API on a Linux box. This right here would work on any x86 or ARM style Linux machine, even like a little, even if you just got a little Raspberry Pi, you know, you just pop this one on one of those and we're in there. Yeah, this looks like it's definitely erroring out. Anyways, this is absolutely. Here's a sample version of the Song of My People, sung by Dutch. Oh, it's making shit up. It's making stuff up. That's all made up. All right, Somebody give me a lead in. We're singing. No, I'm just kidding. I'm not singing. All right. Anyways, he says, great job. Hopefully find a way to create a local LLM. You were able to install Olama and download Tiny LLM. Interact with the model interactively. If you do any of that and then you say, hey, I want to do that Ansible stuff, but I need to tool over this thing for the right, link. I think most of you could probably figure that out. But if you couldn't, just let me know down in the Discord and I'll help you out. This thing's gonna just making shit up, man. There's no way this is real. This is gonna make me go Google this now. Join the prologue. We've got a professional Linux users group. You guys are welcome. This is I'm reading this right here. You guys are welcome to hang out down there. We have almost 1,100 people down there. I was super happy last month when we hit just 1,000. We've been working on that group. I've been running that group for over almost 10 years now. And then, it was just always local at the house. And then after COVID hit, we kind of threw it up on, actually it was a little before COVID hit, we threw it up on Discord and said, we'll just hang out here and talk shop. And then when I started streaming a while back, we just kind of kept telling people go down there, and more people showed up, and it's pretty all right. It's a pretty good little community, good, engineers and architects and security guys and all that stuff. So that's an invite right there that I think is still pretty good for getting in there. All right. That is dead, by the way, because we left that environment, so that makes sense that that's dead. And then there's man, he's still breathing. But man, Ranger looks like dead downstairs. He's just dead tired, apparently. It's hard being a dog with two really nice soft beds and living a life at exactly 73 degrees downstairs. It's real hard. It's real hard. Like how could you survive that, right? Hey, thanks for the follow. Pelaringa, hopefully this stuff's useful to you. Look at that dog. Look at him. Alright. So here's what we're doing. We're on this last of these monitoring labs. And then wait, did we just do this one? Yeah, we just did the telemetry one, so now we're gonna do influx Grafana. So this one is a little longer on the page here. This is another one that falls into the category here of the way that I do this, right? We've got our Telegraph agent feeding over to InfluxDB2, and then Grafana monitoring is pulling data out of that. So we're going to do this part of our monitoring architecture here, right? By the way, I did share this earlier. If anybody wants this picture, it's right here. You have to fix the link, though. It's not going to work for you. I'll put it also in the live stream. On the YouTube side. The link itself has a comma in it, so you have to copy it out and go drop it in your browser. But then you could have this, and I don't care if you break this one because I already have a saved copy of it. But this is you could be working on this one with me. We could be drawing on it. Right. Anyways, there you go. All right. Get out of there, and we'll do this next lab here. Wait, did somebody? I thought I saw somebody pop in there right at the thing. Yep, somebody else is in here, and then that person can do whatever. I also was showing. Yeah, see, there's their mouse. You can zoom out, you can zoom in, you can copy things, and then also across the top you've got this. Also, for some of you, you're probably looking at it and it's like in white. It's in bad. Then you go over here and you change it to dark mode. And then you're looking at it like me, because this does pop up in light mode for other people, so you guys switch it over to dark mode. And then yeah, you could draw stuff. I have a little stylus, so I can draw over here. Right, there's my little stylus. And I can also remove everything I don't want. Right, get rid of all my stuff. And I'll move that down because I'm always terrified of what people are going to do on stream. Okay, Ranger's moving around. He's looking. He very much, when he looks right at you, has kind of like the Dobby the ears type, or Dobby the elf type ears. Oh, he's so old. He takes so long to stand up now because he's so old. Now he's gonna spin a little bit, and he's gonna lay back down. And I'm very glad his beds are big and soft because man, when he drops that hip on like the tile. You're like, are you okay, bro? Like, that was really hard. Like, he hits, like, bone on. It's bad. He's a lazy dog, but whatever. All right. We're going to do this lab, and then we're going to do more labs. I also have some project stuff I kind of want to get together, so we might work on a little project stuff tonight. Just depends. Just depends on what we get to. So, all right. And Ranger does not approve of any of our shenanigans. So we'll go to Killer Coda, and we'll pop over here. And by the way, look at all this other stuff on Killer Coda. If you're like, Scott, I can't stand your labs, they're terrible. One, that doesn't hurt my feelings. Go find literally anything else here to go study. There's all kinds of stuff. I would just tell you, like, if you don't have a good chance right now to get your hands on the keyboard, here's all these ways to get your hands on the keyboard right here. So this is our labs, Het Tanis. That's the Prolog labs. We've got all these other ones, but we're doing Linux labs right now. We'll get into Ansible ones later. And then we come down here, and we were in the last of our Linux configuration ones for InfluxDB. So we're going to do InfluxDB. And let me pin this lab for people that want to do it with me. I don't think anybody's been doing labs with me, but if you have, here it is. Pin that lab. And we'll leave it up until the end of stream. I'll also drop it over here for people that want to see it on the YouTube side of things, in case anybody's around. And there we go. Okay. It's going to take a little while to come up, but while it is, we're going to read. Your team has determined they need to monitor telemetry in your environment. That telemetry is always data at a distance. That's all it means. You know that Grafana can do that as a visualization tool, so you plan to deploy it as a server, on a server as a daemon. Deploy Grafana. This is the same thing we've done in the other two labs. There's some docs if you want to read about it a little bit. And then I say to install a couple of these dependencies for Grafana. So we'll get those dependencies going. Then we'll install the keyring. We'll download the GPG key from them and put it into our keyring. Very common standard type thing. What that is that is an out-of-band way of having a trusted key, so that then we say, okay, we're going to use that key in the repository. So we've downloaded it directly from their site. Now when we go and download anything out of their repository, we compare it to that key, and it better have been signed by it. That's what we're doing. So if it wasn't signed by it, sometimes in the lab I'll change that key, I'll break it, go change one value. It will not accept and download this then. It'll say, hey guy, it's not signed correctly. It's because the problem's on our end, but still the point is it's there. All right. Here's some questions. Build a telemetry monitoring pipeline with Telegraph, InfluxDB, and Grafana. That's a task condition standard. Reflection questions. Why do you think it takes some time for Grafana to start listening on the port? It takes about 10 to 15 seconds because Grafana's lazy. It takes a little while to come up the first time. Why do you think it's important to make sure that it's up before you continue? Well, you can't connect to it if it's not up, right? What options do you have to review the data initially in the InfluxDB dashboard? Well, we can go and look at the data and look at the different ways to load data. And it says, what are the two buckets that are set up by default? If you found monitoring and tasks, what data is inside of them? So if there were two, what were they and what was in there? What is their default retention period? So this is all stuff that's going to come up here in a little bit. So we've got Grafana, we're going to start it, and then we're going to go look, and it's not listening yet. The port's not open. So if I click this, we'll get nothing because it's not up, right? Doesn't make any sense. It's still not up yet. Give it a few more seconds though. The process is running, but the server is not listening yet. Then we go, and now it's listening. So now when I click on this, I get dropped into Grafana. Your default username and password are right here. Admin, admin. And then you're going to go and change and change that up. So admin, admin. It's going to say that's not secure. We know it's not secure. I hate how helpful, I just hate how helpful Chrome tries to be right there. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. And then Chrome's going to try to be real helpful again. I don't want you to remember it. Thank you. And there we go. That's Grafana setup. We've done that 3 times now in the last hour. So I think you guys that's stuck with it and did it a few times probably feel like you're experts at it. Your team has decided that the data will be collected by Telegraph and sent for aggregation to InfluxDB version 2.7. So we're going to install InfluxDB. We're going to verify that it's running. And then we're going to set up an organization, a bucket, and a token, and we're going to save that data so that we have it. Here's... Oh, Oh man. Here's how we download the key and build the thing in one. We'll do it in one command there. Oh man. I don't want to get in a sneezing fit right here. My wife makes fun of me when I sneeze a lot. She'll just be like, "You okay?" She's like, "You sneeze really loud," and I'm like, "Calm down, woman. I'm not dying just yet." All right. Anyway, so we did an update, and then we're installing InfluxDB2. No viruses allowed, please. Yeah, right. Now we're going to start InfluxDB, and then we're going to go look at it. So right here, SS NTOP, we see that it's listening on port 8086. And down here, what I like to do is I like to open an image in a new tab. So there's the data. We're going to set up a user, a password, and then we're going to give it a lab and a test. All right, so that's just an image. You don't have to save the image if you don't want, but if it's real small, just open it in a new tab and you'll be able to see it. So I'm going to click on this, and for my initial setup of Grafana, it's going to say, well, what's going on here? It's like Steam popping up. I don't want Steam. All right, here's my InfluxDB. That was weird that my Steam just popped up like that. It's actually really weird. Anyway, so username is going to be het. Password will be some password. 1, 2, 3, 4, 5, 6, 7, 8. Right? Something super secure. And then initial name will be lab, and the bucket will be test. And that'll be easy to remember, I hope. Lab test. Now, okay, we don't want it. Come on, get the fuck out of the way. Jesus Christ, man. All right, we're going to copy this. Fuck, man. We're going to copy this. I can't stand how much Chrome wants to help me. It's like, get the fuck out of the way. All right, calm down. That's just so annoying, though. All right, we're going to save that key. Normally, we wouldn't be saving it like that, but for now, we're just going to save it out here. And then we've got our API token, all right? We can then immediately go in and start looking at stuff if we want. Go in, look at our buckets. So I said, how many, like what buckets do we have? And we have monitoring and tasks. And you can see that one is retained for 7 days. That's our monitoring. And our tasks are retained for 3 days. So they don't stay in there forever. But they are buckets that we could query. And then now we have this test bucket. And this test bucket is in our, so if we go back over here, so bucket, so org was lab and bucket was test, right? We need that here in a little bit. We've got that. So when we come back over here and we say that that's all set up, but we have our data stored off. It said in your research you find that Telegraph can write out to InfluxDB. So Telegraph is a tool that we're going to set up. So we're going to install Telegraph. We're going to configure it to push data over there. And then we're going to verify that Telegraph is running and pushing data over where we expect. So here's our thing. We're going to download. We already have those, but we're going to download them again. And then we're going to install Telegraph from that same repository. Because Telegraph works with InfluxDB directly. Telegraph also has a tremendous amount of plugins. And one of the main ones that I've seen it used for is we can write to Kafka. Telegraph to Kafka. Kafka has a bus that goes around your whole organization. Another Telegraph is pulling data out and feeding it up into InfluxDB somewhere else. There's like a whole case study from Wayfair from a few years back that's pretty good on that. We'll go look at our Etsy Telegraph, and there's a bunch of information in there, but this is what we need to change. I'm going to say /InfluxDB_v2. By the way, I'm pulling that from right here on the left. I'm not making it up. It's right there. I'm going to hit enter, and it'll find it for me. And now I have to comment out, I have to uncomment the things that are commented that I need to run. So I need this to be able to use that as an output. And then I need the URL. Look, this is all right here. 1, 2, 3, 4, 5 things that I have to fix. I need to have a token. This token is that token, that token that I copied earlier. There's my token. And it seems to me like we don't have that on the end of it anymore. All right, so anyways, we need that to be like that. Okay, good. We need to uncomment the organization and the bucket. The organization was lab and the bucket was test, right? If we have that 1, 2, 3, 4, 5 things fixed right there, by the way, it maps to 1, 2, 3, 4, 5 things right here fixed. You don't use what's in the example here. The example is wrong. What's right for you is what you just set up. Escape : WQ. We got to restart Telegraph. And one of the things we'll see is right here it says I'm loading the output InfluxDB2 and I'm writing out. And I say, okay, that's good. Now if I come back over here and I look at my buckets and then I go into test, if data are flowing, almost immediately inside a test I should start to see all these measurements. These measurements are coming from Telegraph by default. So now I can go to System, Load 1, Load 15, Load 5, and then I can say right here, Submit. And now right here, I have the 1 and the 5 and the 15-minute load for this system. Very similar to what we saw earlier. One of the reasons you don't you don't just give users access directly to this is because this is not really user-friendly. This is kind of like your exploratory data science. As you're ingesting data in here, you can look at this, but this dashboard isn't really something you would give to users ever, this kind of raw dashboard. What we're going to do now is we're going to go over to Grafana and we're going to set this up as a data source, and we're going to read this data out, and then we're going to build the same exact queries right here, and we're going to save these queries. We're going to steal these queries, as it were, and put them into Grafana and make these little same monitors but inside of Grafana. So watch this. We go to Grafana. By the way, in the lab it'll say check, and it says let's go in and let's make an InfluxDB2 data source inside of Grafana. So here's the next part of the lab. Go to Grafana, set up the data source, make sure it's working with the 3 buckets. We should see 3 buckets, and then we'll go in and we'll make a new dashboard, and we'll actually make one of these things, right? So we go over to Grafana. We're going to make a new connection. This is InfluxDB. Right here, InfluxDB. We're going to add a new data source. All these things are being said right here. Make sure you use the Flux query language. Make sure you use 127.001:8086. All these things are here. So InfluxDB, Influx query language is going to change to Flux query language because that's the newer one. We're going to come down here and we're going to make this HTTP 127.0.0.1 on port 8086, right? That's the InfluxDB port. If I forget that, it says it right there, 8086. Good. Come down here, I don't have any special things, but I do have an organization, which is lab, and I do have a test bucket, and I do have a token over here that I need to remember. And I don't need to remember it, I can just throw it in a notepad, right? But there's our token. You also need to make sure it's on one line, because if it's not on one line, this won't work. If I save and test this, this will only read if these are right. These are right. Three buckets found. Good. So now we say, okay, that's good. Let's go back here. Let's make a dashboard. So we'll make a dashboard, and I'll just say make me a new dashboard. Add a visualization. We're going to use InfluxDB as the data source, right? Because the data has to flow. The data are flowing the entirety of this place. Let's get this out of the way. Let's come back over here. Let's look here. Let's grab this. Let's steal this from ourselves. This is a visualization that if we keep running will give us the 1, the 5, and the 15 minute. But if I come over here and just drop it right here, and then I say apply, it's going to go read. Give it a second here. Let's edit. Let's actually run it. Where's the little thing to run it? I thought it was right. I thought it was right at the top here. We'll apply it and we'll refresh it, and there we go. And then we can set it to refresh every 10 seconds, and we can change this panel title to be, this can be right, whatever you want. CPU 1, 5, 15 minute load. And you can save that and apply it, and that's okay. That's good. But then we can go pull other information out of there. We can come back over here, go back to our query builder, cut all this stuff off. We can get rid of all this stuff, right? Come back here to disk, go to control plane, scroll to the right a little bit. Oops, come on. It's because I don't have enough space here. And then down here, maybe I want to have total and used for my disk, and then I'll submit that. And that's kind of nice. There's my total disk size right there. There's my used disk size for And maybe I only want VDA. I really only want VDA 1. So there's my total, and there's my used, right? My total disk. There's my used disk. So watch this. We're going to save this now. We're going to go script editor, grab this, boom, come over here. We'll just make a new one of these little visualizations. Where do? We add it. Add visualization. We'll say InfluxDB. We'll drop this query in, and we'll say disk usage, right? Disk usage, something like that. Now we've got these, but why don't we test? Why don't we like mess with the server a little bit and say, well, here I go df-h and I have df-h on home, and I've got 9.9 gigs available. So what if I go like this and I say dd in file is equal to dev 0, right? Out file is equal to root big file. Block size is equal to 1024K. That's 1 meg. And count is equal to 5,000 of those. So that's going to be a 5 gig file written to the system, right? 1 5 gig file coming right up. And over here on this dashboard, refreshing every 5 seconds, we should see this spike right here for the disk usage, the overall disk usage, if we're looking at that right. We should. Yeah, we've got the used and the total. Yeah, there it is. There it spiked. We just used half of what was there. Half of what was available. By the way, that's not good. It was half used. So what we're seeing here is not a good scale. I need the scale right here to be the minimum unit is not automatic. It should be 0. I want the minimum to be 0 and apply that. So now that's about what we expected, because we were half using the system, right? We were using almost 10 gigs, and then we just added another 5 gigs. So that's about the scale that we expected. Also, maybe we don't like that, so we could shorten that down and express it in gigs, right? By doing division, divide it by a billion, and then it would be only as 20 gigs, right? So you could do all kinds of things here and start to build out your visualization, save your dashboard, and start to show this for different nodes. We're only logging one node, but in my Homelab, I have all these nodes. These are all kinds of different servers reporting their uptime, how many users are on them, how their CPU is doing. And their CPU spikes every night, and their server memory spikes every night. That's when I run my antivirus, right? Which I run in my environment just as a little thing to test, right? But this is how my Homelab is set up with a lot of this stuff. How much of my network storage is being used? I'm using a lot on some of it. How much of the root storage of my servers that I care about is being used? Right here. I need to relabel these, because the names are over here as host, and I need that to just be the whole thing. But anyways, it doesn't really matter that much. But these are my Homelab ones, right? Of these same things that we've been looking at this whole time, right? Here's my security information about what's going on in the environment. So, all right. So if you did the lab with me, you've now got something like this. It's gonna be, that's the last 6 hours. Let's change it to like the last 30 minutes, and it's a little more like obvious what we're doing. By the way, let's go clear out that big file. rm-rf root big file. Now come back over here, and we will see in real time this is going to drop to right here. Well, within about 5 seconds or so. So the data is going to flow all the way over. It gets pushed every 10 seconds from Telegraph to InfluxDB. It gets queried as fast as it can out of here. And then there's page refreshes every 5 seconds. So I would say within about 15 seconds, we should have seen that drop like we just did. By the way, we can do the same CPU load spikes on the 1, the 5, and the 15-minute load average if we wanted to, just like we did on the thing earlier. So we have, look at all these things you can do. All these capabilities. We've got all the capabilities. As we say, as Dutch says, where's Dutch at? I don't have many of these. If it bleeds data, we can monitor it, right? If we can get data out of it, we can look at it and see what's going on with it, right? So here's the question: what's the default retention periods on those little labs that were in there over here? The default retention periods were 7 days and 3 days, but the test is retained forever unless we run out of data on the server, right? What are the basic functions you see inside Telegraph configuration, etc, telegraph.conf. There are, if we go look at that right here, if we ls and then we cat etsy telegraph and then telegraph.conf. Oops, .conf. It's gonna be way too much stuff to the screen for us to ever read, but if we come here and go find one of these, let's go with I want to find one of these values so I can see it. Hold on. There's a bunch of stuff, but there's only a few things that it. You know what? Hold on. Telegraph input plugins. We'll do it this way. Here's the plugin directory. I'll give you guys the plugin directory right here. So plugin directory for you guys. Plugin directory for you guys over on the old YouTube side if anybody's watching on YouTube. And Goddammer, thanks for the follow. Here's what happens: input, output, and aggregation. They also have process. So typically in computer science we have input, process, and output, right? But they also have this other one called aggregator. External, I had never seen external before, but it was always input, process, output, and then there's an aggregator function, which is technically still just a processor. And then, but I can click on this and I can go look through, and here's the external ones that Telegraph can go read. And I do some of these. I use Amazon CloudWatch. I use that one in my Homelab. And the other one that I use is, oh, you got a Plex webhook if you want to pull data out of your Plex. There's a YouTube one if you want to gather your YouTube data. GeoIP, MaxMind, and adds it by that. I might want the GeoIP processor for some data that I'm doing here soon. But here's all the things that Telegraph can do. Telegraph can transport, it doesn't just have to input and output data. So we have an output in our Telegraph that we changed, or we added the InfluxDB to Flux, right? So that was the one that we modified, those 5 values. But the inputs were already there, and the inputs were things like the very specific system and disk. All of those things were already set up. But look at all these other things you can pull out of here as well. And in my Homelab, I've shown you guys this before, my Homelab pulls weather data. It pulls all kinds of stuff from all over the place. So there's like all kinds of stuff. Also, CloudWatch is Amazon. It is not a it's not a weather data thing. CloudWatch is how your cloud VPCs and endpoints and all that kind of crap are doing, right? But yeah, look at this. Here's our little server. There's where we added 5 gigs of data to it. And then when it came back down, here's our overall. And then, by the way, we could build into this like a high watermark. We could go in here and we can mess around with this and say, you know what? It's going to be red at a certain threshold where it gets a certain height of this. So we could do 80%, and then it could be based off of like a percentage, 80% of whatever. You can also throw it away. You can add thresholds, maybe one at 90%, and then I should be able to apply that. And I may have to put those based off of a top value. Here's my little thing. Anyways, you could yeah, show thresholds as lines. There we go. So that's a 90%, or look, as lines dashed if you want them as dashed. Filled regions, right? So what constitutes red? What constitutes green? I'm colorblind, but somewhere in between there is something else. As filled regions with lines, and then also as filled regions with lines dashboard. Also, this should technically be 80%, and this one should be, whoops, and this one to me should be 90%, right? Right, because that makes more sense to me. We should be yellow before we're red, right? I thought those numbers looked weird, and I'm colorblind, but they still looked weird to me. And maybe that's the one that makes the most sense to you, right? But and look, this is your visualization. Use whatever you want. You know, use whatever one looks good to you when you come back out here. So now I almost hit that high water mark. Now this isn't alerting yet. We have to go set up the alerts, but that is the start of setting the alerts up. Also, the alerts, you set up your contact points, so manage our contact points, and the first one, you can't get rid of the default one, but you can add a new one and make it the default and then get rid of the default. Email, garbage. I don't like email and shit. I prefer to send things to, look at all these things you can send to Discord if you've got a webhook, which we do in some of our labs. Just a direct webhook if you're sending to Teams. That'll work that way. Slack if you got to send to Slack. Opsgene. Oh, Microsoft Teams right there too. But if you just have a webhook, which you do with some of these tools, you can send it directly to a webhook as well. So if you want to build your own format, you are allowed to do that. Methods, anything, any kind of default data that you want to send in there, you can do that. And what you do is you define the contact point and then you tie the contact point to the alerts. But one contact point has to be default. And you can't get rid of that other one until you make this one default and get rid of the email one. And then this one would become the default one. So, okay. All right, so I hammered that a lot. Oh, I wanted to do something else in that lab, but I'm not going to do it right now. And then I talk about, once you've completed the lab and gotten the data to flow, you may want to go back into the Influx GUI and explore the data, what differences are there. Query builder and the script editor, we did all those things in that lab right there. Then I said experiment with pulling scripts from the InfluxDB script editor and putting them into a new Grafana dashboard. Do the queries work properly? Did the visualizations work like we expected? And I'd say all those things did. In the enterprise, data gathering in the enterprise is critical for baselining systems and determining their health states. Keeping track of system metrics will help with operation and optimization of systems. That's 100% true. And I would pull up my little thing in VS Code, except that shit keeps crashing for some dumb reason. That's always fun, right? All right. So what's our next lab? Our next lab goes into our security labs. Actually, installing antivirus is still technically a config lab. And then so is installing Slurm. And then this one is where when we get to 200s, that's when we're doing security stuff. So we got more labs to do. I got more time to work on stuff here. So what I'm going to do is I'm going to pop this here. I'm going to do a little bit of a break. And then if anybody wants to, our next lab will be installing antivirus. So I'm going to set a little hourglass thing up here and say hourglass, take a break, and then more labs. Antivirus. In Linux. Actually, antivirus in Linux never used to be a thing, but now it kind of is a thing. So, like PCI DSS environments tend to require it. So, all right, I'm going to be right back. Feel free to smoke them if you got them, do any of that stuff. I got to check my phone messages. I'll be around. Alright, I'm back. But, still taking a break. There is our Discord. If anybody wants it. If you want to go hang out down there. Talk shop, you guys are welcome to. A ranger dog down there. If you guys have any questions about that stuff so far, let me know. We're just going to keep rolling on through all the labs. We've been doing all the labs yesterday and today. We're just going to keep rolling through them. Did I turn off my... Playing with my media player sound. Hopefully that's not too loud for you guys. So we're going to keep hammering through everything in the book. So we'll let this thing finish here and then we'll get back to it. There we go. All right. Give that another minute and then we'll start up here. Killer Coda. Well, here's the lab link right here, actually. Make sure the lab works. And this one is called Installing Antivirus. So I'll unpin the last message. If anybody wants to do this with me, you can. We are going to install antivirus on a system. And I will also put this on the YouTube side for anybody on YouTube that wants to do the lab with me. Killer Code is free, so you can do whatever you want in there. And here we go. Well, I'll give it few more seconds here, because some people might have been still taking a break. I don't want to get back too quick. But this one is, the task is going to be to install antivirus and set it to run on a set timeline. So that's something we'll do. Condition: given a bash prompt, complete in the allotted 60 minutes time. That's good. Complete all activities and the lab. Verify that antivirus is running on a schedule. Good. And then I say, how does it prove that you've installed Clam AV to run which clam scan and which fresh clam? Like, how does that work? And then when you run fresh clam, what are the 3 types of database that you see updated? And what do those 3 databases do for Clam antivirus? So we're using Clam antivirus. Full disclosure, if you don't know this, Clam antivirus is not just an open source tool anymore. It is open source still, but it is owned by Cisco. And if you didn't know that, you can go to Clam AV, and you can scroll all the way down to the bottom, and there's your little Cisco logo. So if you didn't know that, there you go. And man, that's the way it is on almost everything, man. Everything's open source, but everything's owned by somebody. And most recently, HashiCorp getting bought up by IBM, but Red Hat 5 years ago now getting bought up by IBM. You know, everybody owns one of them. And Microsoft has so many hooks down into open source technologies where they're writing, you know, majority of code that they use, and then they eventually buy stuff out and take it over, and you know, it's the way it is. But just so you guys know, Clam was a long time project that was open source, but it got bought by Cisco a while back. So you can go look that up if you want. All right. So your team has determined they need to run an antivirus program on your servers. This satisfied the PCI DSS requirement that your security team has identified. It used to read, the server standard used to read, for systems that were prone to antivirus or prone to viruses, you must have an antivirus on them. And those of us in the Linux world, we used to say, well, we're not prone to viruses, so we don't need it. But the fight has eventually caused that to change, and now the PCI DSS standard basically just says if you're a server, you need an antivirus. So even our Linux boxes that really don't get many viruses on them, we still got to run Clam AV in our PCI DSS environments. And if you've never ran that, that's the payment card industry, and I forget what the DSS part of it stands for, but it's basically if your organization takes credit cards. And I can almost guarantee you that your organization takes credit cards. This is one of the reasons those like Square and other tools like that are so popular, because somebody else is doing your payment card processing for you and you don't have to worry about it. But if you're a big enough organization, you do deal with PCI DSS quite a bit in the industry. So we're going to install, we're going to make sure the system has up-to-date metadata on all of its repositories. So we do that. And then we say, from the default repositories, give me Clam Antivirus and the Clam Antivirus daemon. We're just going to install all of it. And then we get to one of our first questions that says, well, when you do which clam scan and which fresh clam, why is that showing you that you've properly installed it? Well, the answer is because if you have the binaries, they're going to be in your path. They're going to be installed properly to the path. So when this is done, we'll do that, and we see user bin clam scan, user bin fresh clam. We're good. Now that you've installed it, let's move on to the next part of the lab. You've installed Clam AV in support of your team's PCI DSS directive by security. We know why we're here. You know that antivirus works on signatures, so update the signature database and verify that the scanning engine works properly. So this is a test for us. So first we'll update the signature database. There's a tool called Fresh Clam that will update the Clam antivirus signatures, and then you can also scan your system for vulnerabilities. So we're going to stop the Clam AV Fresh Clam service that was running. We're going to run Fresh Clam by itself, and it's going to tell us that it went to update. There's a daily CVD database, there's a main CVD database, and there's a bytecode CVD database. Those are the 3 types of databases. And they keep signatures here. There are, in the daily CVD database, there are about 2 million signatures, about 2.06 million. In the main one, there's 6.6 million. Is that right? Yeah, hold on. Yeah, 6.6 million database antiviruses. And then in the the bytecode one, there's only like 86 of them. But that's because there's not that many bytecode things, but it can still scan for the ones that it knows about. Okay? And we did update it, so we have antivirus, we've updated it, we're good. So now we need to test to make sure that it works. So we'll turn that back on. We'll let that, what that is doing in the background is making sure that those are being downloaded daily. Good. And we're going to do a really quick little clam scan. We're going to look for the infected and we're going to remove them. And then recursively, we're going to go into /etc as a directory. But over here, we're going to log out to var log clamav.log. And we're going to wrap it in the time command, just because the time command will give us the total time it took to scan that directory. There's going to be a lot of information given to us, but we're also going to have the little time. It's like a little stopwatch before and after, and it tells us how long it took. It also tells us 3 times. It gives us the wall clock time, which is the real time. It gives us the system time that's calls against the system are happening, and user time of user calls that are happening against the kernel. So wall clock time, real time, kernel messages like system messages against kernel, and user messages against the kernel. But then also we see here's the 8.6 million, almost 8.7 million total known viruses that we looked at. And we looked in all these signatures. We scanned 251 directories under etc. We scanned 764 total files, not very big because they're mostly config files. And we found nothing infected. Here's the full time it took, right? And then here is the real time right here that it took 30 seconds according to our system. And right here it thought it took about 30 seconds as well. So that's pretty close right there. That's close enough to eyeball it and to say it's accurate. It used a lot of user calls against the system. The user was opening, or the user that was running this was opening a lot of files, and very little system kernel calls, right? Mostly files and stuff like that. But that's how the time was broken down. By the way, I sometimes show this here. We can time sleep 10, and if sleep 10 simply sleeps for 10 seconds, what do we think this output's going to be? There's going to be a real 10 seconds, and then user and sys are probably going to be unused, right? Like, because the system was literally just sitting here doing nothing. So time is this really awesome command for, like, not only how long did things take as like a little time, like a little stopwatch, and then I can give that to my engineers and say, hey, this process is going to take like 15 minutes. So go grab yourself a cup of coffee when you're doing this on Thursday night. I'll be in, like, next Friday, I'm going to be in Mexico for a week. And this is real. I'm telling you guys this for real. I'll be gone, and I'll be like, hey, engineers, by the way, this thing that you're doing on Thursday night or whatever next week, here's how long it takes, because I timed everything when I set up the procedures, right? And I do that with my engineers, especially if something's going to take some time. So let me show you something that I don't have over here. I don't have it over here at all, because I think I did this later. Let's make this thing give us an error. Not an error, but let's find an infected file. So does anybody know how we can go find an infected file? Like class, does anybody know? Can answer that for money. That's what some of you are thinking. I know how to answer that. I can answer it for money. That's what some of you guys are thinking. All right, here's the answer. We're going to go over here to Wikipedia, EICAR. Right? You can download, you can find bad stuff. But EICAR is a test file that you can use inside of systems. And here's our EICAR string. So grab this string. Just grab the string right there. Here it is. That's the string. Drop it into any antivirus system. So we'll vi etc bad file. Doesn't really matter what we call it. And in here, we're going to just drop that. Whoops. Did it? What? Yeah, there it is. There's the whole thing. Escape::WQ. And I'm going to rerun that 30-second scan or so. It's going to take about 30 seconds. And now we're going to see, does it find that one file? Does it find it and think it's infected? If you want to read about the EICAR test, it is a simple test that always comes up true with modern antivirus programs. It is a signature that is found to test, well, does this thing actually work? Right? I mean, it could literally just sit around for 30 seconds and tell me, looks good, buddy. I mean, how would I know? This will always be found by modern anything. You can put this in your Windows box and run Norton and it'll find it. EICAR is a common signature that people use to just give not false positives, but it's a real positive that we expect to make sure that the system's actually scanning what it says it is. Like, here we go. We found one file. And the file was called bad file. And because we said remove, it removed it. So it's not there anymore. I have to put that back in there for my next scans if I want. How long did the scan take? About 30 seconds again. Verify that the file was written out there. So we'll cat that out. And there's our thing. And there's it finding that EICAR signature found, and it was removed. So that's also a thing to know, is if you ever see that EICAR, it was just somebody testing something, right? That is not a real virus signature. It's just always triggers as a virus signature, right? Like, if you ever seen like when they're training like a model or something, and they always use like a red dot or something like that, and the red dot is there to be like a control. That's kind of what that is. It's like a control. It will validate that things are working the way they should. All right. I'll stop beating that point up because we're going to get to the long part here. And you've installed it. You've made sure that it works. Now we're going to set a script. We're going to run this script and let it scan everything in the company. If we want to, we can go remake that bad file. I'm going to hit I in there and then paste it. And I'll paste the actual test file again. Copy, Control-Shift-V, Escape, :WQ. And now we're going to come in here and we're going to change this answers clam scan, and then we're going to go look at it and make sure that it's 755 executable, good. And then we're going to cat it. And this is the simplest little file. Here's me. I wrote this back in 2019. We have a daily file and a log file so that we always rotate back. And then we've got a clam scan RI against everything, gets thrown into log file. Then when we're done, we copy log file to the daily log file. And then we scan out of daily log file for some values, and we report them out to the screen. What I used to do with this in my Homelab is I would do the same thing, and then I would send them into InfluxDB. And then InfluxDB used to keep all this information for me. In fact, that used to exist right here. And this used to write out to my old Telegraph, or to the old database. This doesn't work anymore because you can't just X post and write things. You actually have to have the token now. So I could modify that and make that post. But when this runs every night, it could be feeding data over to Telegraph. It used to feed data, and I would have all my scanning every day. But anyways, this is the original one written by me. Right? All right. It's modified in here, and all it does is print out to the screen, right? So now we're going to say how many files are being created in each run. Why do you think this is? Well, it's always going to create the one for today that's always spinning, and it saves one back so that we always have stamped daily what each value is. And then I say to run it, and it's going to take like 10 or 15 minutes to run it. So feel free to read about this a little bit. Maybe we'll go check on Ranger. What's Ranger doing? No, he's just laying there. This is going to take like 10 to 15 minutes to run, so we can kind of hang out and work on something else for a little bit if we want. We'd even do a round of Brotato if we want. Nah, we're not going to do any Brotato tonight, but it is interesting to me that this popped up on my screen a little while ago. This just like popped up here. I'll move it over here. I normally keep this on a different window. I don't know why it would have came up over there. Also, we were talking about Brotato is going to be coming out with a new update. So there's more Brotato coming soon. I never got into Death Must Die. I don't know if any of you guys saw that. That game's not super great, but alright, anyways. I kind of feel like it's also pretty late too, because like people were talking earlier today and like hardly anybody's talking now. So or typing at least. I don't know if maybe it's just a lazy Saturday or something, but I don't know. Alright, so that's going to scan. That's going to go for a bit. And then when we're done, we're going to see if there's any output. Did we see any antivirus? We're going to be scanning a lot larger number. So the scale of it compared to this was our old value. We had 251 directories and 765 files total. but now we're doing all of root with like 10 gigs of data in it. This is going to be significantly more scanning time. Again, like 10 to 15 minutes, and we can kind of keep an eye on that. But know that if we can throw it to a log file, we can go do something with that log, right? We can do something with this data if we want to. If we want to throw it out to Loki, we could do that. If we had Loki in this infrastructure, we built that a couple hours, or I don't know, maybe an hour or two ago. So installing antivirus, like I said, how long did it take to run against everything? Again, that's going to take like a while. And I said, how does adding the script to etc cron.daily differ from adding it to crontab? Cron.daily runs at 3:14 in the morning on most modern Linux. It doesn't really deviate from that. In crontab, you can tell it to run exactly when you want to. And I think in our crontab example, we're going to set it for like 1 a.m. So at 1 a.m. it'll run. And then if we also left it in etccron.daily, it would run at 3:14 a.m. every day. Then I say over here, in PCI environments, there are often requirements to have an antivirus scanner on your systems. That's very true nowadays. PCI DSS version 4 came out. I think it was hard-coded last August. You had to be in compliance with it. I believe it was, 2023 August. And there's one more thing to do to provide compliance in the environment. There's always compliance. More importantly, though, as an administrator, this gives the ability to detect anomalies within systems and correct them before they get into the rest of the systems. There are other ways to detect anomalies in systems, but an antivirus program with 8.6 million ways that have been compromised before is a pretty okay one. If you're okay with losing that little bit of processing, it's a pretty good one. Another one that's very good is like a tripwire type system. Tripwire type systems are ones that just go out and they just check the weight as a hash of files to make sure that files don't change. Files can be accessed, they can be created, but if they are modified and they're one of the ones that Tripwire is watching, it will alert you. That's all it does, and that's kind of a useful thing. Also, it says the ad's going to start. I'm going to let the ad run because there's no reason not to let the ad run right now while we're just sitting here waiting on this, right? Might as well just sit here and wait quietly for this system to finish doing what it's doing. By the way, the lab is pinned, so anybody that got here later that wants to click on the lab and do stuff, you can. And thanks for anybody that followed recently. You guys are welcome to hang out as much as you want or as little as you want. I am ambivalent to all that. I do appreciate when people are hanging out, though. I mean, it's always fun. It's motivating to have people that are interested in doing Linux with me and doing systems work and stuff. We also have a bunch of people down in the Discord that are, security guys, and we've got quite a few architects in the cloud space. Quite a few of us have our golden jackets. Well, we don't have our golden jackets yet, but we have parts of our golden jackets. And if you don't know about the golden jacket, that is when you get all 12 of the AWS certs. I have 5 of them, 5 of the 12. Fisherman has 6 of the 12. And, I haven't been working on mine very hard because I've been doing my doctorate, but they're kind of fun. Just studying for those certs and going out and wrecking them. The highest one both of us have gotten is the Solutions Architect Pro, but also he and I both have the security cert, the security specialty as well. So if you guys ever want to talk security in the cloud space, we're pretty capable of that kind of stuff as well. Although, quite a few guys down in our server. I know of at least 3 of our guys that work for Amazon. So we might have more of them. But at least 3 that I know personally. So all right. So that thing's gonna run. What could we do while we're waiting? We could. What else could we do while we're waiting? What was this? Oh yeah, that was that thing earlier. Data security. Solutions Architect Pro. Security stuff. Security primer. Yeah, we're good right now. We'll hold off. But we'll give this a little bit of time here. Alright. Oh, on the wrong one. There we go. All right. Pop myself back up here, and there we go. All right. That's going to run for some time. Oh, by the way, you can open up a new tab. If you're bored, like I kind of am, you can pull up a new tab and do this real quick. Watch this. This is kind of a fun one. We could say bigger window and do ps-ef grep-i for clam, because there's not going to be too much clam stuff going on. And then here's the process ID for clam. So watch this. We could say watch a lsof-p for that, right? And I like to wrap those like this. And lsof-p will show what files a process is opening. So that's fresh clam. Wait, answers clam scan. Yeah, so this is the oh, we want this one. We want the 5072 because this is the actual. No, we want that. We want this one. 5023 because that's the actual scan. So watch this. 5023. This is kind of fun if you guys have never seen this. I used to run this when I was trying to figure out how long things would take. So this right here, every 2 seconds, this is gonna tell us. So every 2 seconds, what's this doing here? Oh, it must not. Oh, no. Where was it? Oh, there it is. Okay. So every 2 seconds, this is gonna change, and it's gonna tell us what it's scanning. So this is telling us what the system is scanning, and what we're specifically looking at is that process that's scanning systems or that's scanning our stuff. It is opening what files lsof-p against the process will tell us what files it's looking at. So we should be watching those. Those should be changing over time, but there looks like it's probably deep scanning some of those. And this also, it might be going off the bottom of the screen as well, meaning that if I make this just a little bit smaller, let's see. I don't know how many threads total it's going to run on, but let's go a little smaller. That's all the things, and now at the bottom, you're going to see the ones that it's scanning. So it's in user source Linux headers right now. Those other ones are the libraries it actually has open at the top. So at the bottom, it's churning through. So we like, now we got a little thing to watch, right? Because it's always boring to just sit here and be like, okay, like just twiddling our thumbs, like what the hell is this system doing? Now we're actually watching the process running. And the command I used is right at the top there, lsof-p, to look at what files the process is reading at any given time. And there's the actual files it's reading. So we're down in user source Linux headers, so we're almost done. Because it does go alphabetical. So if it's in user /user, it's gone through all the earlier stuff. But yeah, if you've never seen that, that's how you track and watch what a process is doing. So, yep. You also see how much memory it's using on each of them. All kinds of useful, fun things. And you'll notice that it's got its varlog clam av log open. Well, that makes sense because that's the process. That's where it's writing out to when it needs to. Not doing anything yet, but it's got it open. Then this is where it's spinning right here, just churning through right here. Make that a little smaller. But that's it. That's it churning. It's only opening. Like, there's probably a way that we could. I don't know if there's a command we can give. I've never messed with this that much, but can we tell ClamScan, hey buddy, you're allowed to open more than 5 at a time to scan? And we probably could do that. Because look, it's only scanning like, I don't know, like 5 things at a time, 5 or 6. All those other things are just open libraries that it's holding open to do its scanning. So sometimes you want to see what a process is doing. In this case, we know it's walking everything in the system, but we got to go watch it walk all those things in the system. So there we go. And this thing's a good jam for it too. It's like a little cat jam. Watching our antivirus spin. Some of those were obviously taking more processing to get through. Some of these are obviously shorter, but now we're down in Linux GNU Perl. Linux GNU, libglib, gconvert, libcrypto, We got to be getting near the end here. On the other window, we'll see the time, right? So if anybody's doing the lab, when it's done, we'll see the time over there. But here now it's going through the kernel. It's scanning the actual kernel modules right now. Kernel drivers, kernel messages. Now it's jumped over to user lib shim. Again, this is alphabetical. Must be another one of those bossa nova songs. Hey, thanks for the follow. I don't normally lay back in my chair and fall asleep during stream, but it takes a little while to get through the antivirus one here. The questions are on the right, so you should answer. You should, as a litmus test, I always tell you guys, you don't have to like write these up and send them to me, right? Like I'm not your college professor. I'm other people's college professors, but I'm not yours. You can look at those and just, it's a litmus test. Do I at least understand the words that are coming out of my mouth? And if you can't understand the words, then you got to go study a little more. But if you do understand it, but you're like, but I don't know what it really is asking, then it's a little more study as well, or look at the output a little bit more. So there's a lot of ways to use this stuff. It's never to like beat yourself up and be like, I'm not smart enough to do this. You guys are all smart enough to do this. You just got to spend some time with it. Inspector, I dropped off for a few hours earlier and then I came back. But we are running the antivirus and now we're just kind of lazily watching it scan. We're doing an LSOF-P on the process and just watching it open files at the bottom there. So user local Go. There's Go on this box. I didn't know Go was on these servers. Actually, maybe I did know that because you can go look at all the packages that are installed in these lab environments in case you want to do different stuff. So, yeah, I think I'm just over 3 hours again, Inspector, but I think I did about 5 or 6 earlier today too. So, I'm just trying to get through the book. I'm doing all the labs of the book. If anybody is like, hey, I want to do more and more of this stuff and get in there, we're hammering a lot of Linux right now. I also have stuff to do for work on my other box. I just have been putting it off. Maybe I'll do it tomorrow. I have actual work stuff to get ready. Because I want to finish some stuff before I go on vacation for a week. So I need to spend some of this weekend doing it. So I also have to write a paper. And I don't want to write a paper on vacation. So I'm going to write it this next week coming up. So that's one of those choices you got to make. Like, you know, do I want to write on... And here's the real problem. Because my wife's like, you could just write it. And I'm like, yeah, here's the thing though. The laptop I'm going to bring is just a screen this big. But the screens that I'm looking at in front of me, some of you guys have seen in our Discord, I have a massive amount of screen space in front of me right here. Yeah, it's for one of my, it's a PhD thing, yeah. Well, except I'm not getting a PhD, I'm getting a DBA, but it's still a doctorate, yeah. It's still a doctor, it's just not a PhD. I could switch to like a PhD in like learning or something, but I've been teaching adult learners so long that I definitely don't want to get pigeonholed that route. I want to stay in my engineering field. But then again, though, it's funny that everybody's always asking me, what are you getting the PhD for? I'm like, just to check a box. I was doing to check a box. I've been teaching forever. I've been doing engineering forever. It's just, at this point, it's just to check a box. Because if you ever, in academia, it matters, and only in academia does it matter. Like, in academia, people care what's after your name. If you guys don't know that, I just know that. And I deal with a lot of high-performance compute systems that are in the academia space, and people tend to give me, not that I care, but respect, because I know what I'm doing and I know how to build stuff, but people also are always looking at like titles and stuff in the academic space. Whereas like in the engineering space, you show up, do whatever, as long as you do your work, right? Like I don't care. I tell you guys this too, like it doesn't matter if you have degrees and it doesn't matter if you have certs. It matters that you can build this stuff and make this stuff work, right? So I want you guys to, you know, keep that in mind, right? Like the education side thing, I got all these certs and I got all these degrees and stuff. That's not what matters to me. Like I don't care about any of that stuff. Same thing I was talking about earlier. Like there's a thing that happens with junior engineers, especially like wanting to be the smartest guy in the room. It doesn't matter. It does not matter if somebody's smarter than me. I work with all kinds of. I've probably worked with more people that are smarter than me than I've worked with people that I'm smarter than. Because I work with tremendously intelligent engineers. That doesn't matter though. Everybody comes to me because I'm the guy who gets stuff built. And that's not me being a Chad. That's just true, you know. Like, stuff gets built if you just keep doing simple things and getting it working. So, all right. I'm engaged because Inspector's back. What did you miss earlier, Inspector? Not really much. I haven't played any video games today. All I've done is labs, Inspector. We've got up to lab 105, which they're not exactly ordinal. Like, we're not counting to 105, so. Nice prologue books, answers available inside the book as well. No, the answers are not there. You just have to kind of, because they're a lot of this stuff is all open-ended and stuff. So like, there's not really any answers in the book. I never really thought to put answers with it, because it's all like journal, and the answers I think are kind of there. I want to say almost in like a open-ended format, right? Like when you run Fresh Clam, what are the 3 types of databases? You would see that right on the screen, right? Like when we were in that other window, you see it right on the screen what the databases are. So like, I mean, yeah, sorry, I never even thought to put answers in the book. I probably should have a thing at the end, like an appendix with the answers. I guess I never even really thought to do that. Maybe I'll do that. I've called the book, as of like Thursday, I've called the book complete, but I am still going to slide some stuff in here every now and then. And anybody that ever does pick up the book, you always get all the updates forever. You always, like with LeanPub, it always sends you out an email update. So that's a thing too. But yeah, that's actually, I'm put that in my notes. Put in my little notepad. Put it in here. Put in one of these earlier ones. I have a thing here of stuff I need to do. Speaking of, as I just got done talking about being the guy who gets stuff built, and then you see my list of things to do, and I have so much shit I have to do. Where is this at? Not Linux Lab Guides. I have a build out thing. Linux Lab. This is my lab notes to do. Yeah, I can do that. Yeah. I got more technical. I got so much crap to do. I haven't even looked at this screen. This right here, I probably haven't even looked at this for like 3 months. That's so much stuff to do. And then I was gonna do so many more HashiCorp things, but now I'm kind of like I'm in a holding pattern because of the stuff for all the stuff that just happened. IBM buying HashiCorp 3 days ago. Some of you guys probably kept track of that, but IBM just announced 3 days ago that they were buying them. And if you're wondering how I know that, I actually have this in my annotations folder for college stuff. My old references. Here is 24th, IBM to acquire HashiCorp right there. 35 per share in cash, 6.4 billion total. So if you guys didn't know that, they just got picked up by them. Which makes some of that business source licensing stuff last year make a little more sense. Because it was super weird that they did that business source license in August last year. A lot of us were kind of scratching our heads like, what? And honestly, it was probably them positioning themselves to be more ready to get taken over. So, yeah, feel free to go read about that if you want. Here's the link if you guys need it. There's the link. Boom. It's okay if you're, Inspector, mine kind of probably will. There's our EICAR stuff. We saw that earlier. You need this if you're going to test your antivirus and see that things are popping. Let's see if our antivirus is done. It's probably not done yet. Oh, it finished at 18 minutes. Watch. We're going to go to the other window, and LSOF on that dead PID now. That process ID is dead. Well, it doesn't have anything to find anymore. So that makes sense. Come back over here. It took 18 minutes. It did find one infected file. We know what that infected file was because we were the ones that wrote it, right? And then I say, let's do a couple of other things. So we did that time. We're going to come here and we're going to make sure that cron is running. Cron should be running on most Linux systems. In some security postures of government systems, I've turned cron off. I've been told like, hey, we don't need cron, or cron is against our rules. So systemd, if systemd is running, which it will be, you can use systemd timers instead of cron if you need to. And systemd timers are super easy to set up. I need to make that into a lab one of these, and I haven't gotten around to it. We're going to copy our answers clam scan into etsy-cron.daily, and if we cat, so we just ls-l in etsy-cron.daily, in there, here's the things that run daily via cron. And again, cron by default runs those at about 3:14 a.m. That's when those all kick off for the most part. Barring some process, if processes are high, sometimes it'll take a little later. But that's always true with cron. The cron service, when cron is running on a server, it wakes up between the 1st and the 5th second of every minute. It's like a bear coming out of hibernation. It's like, do I got anything to do? It like scratches, and then it's like, nope, and then it goes back to sleep. And then it wakes up between the 1st and the 5th second of every minute, and it's like, and it goes back to sleep. That's what it does. That's like what cron does. Cron is not considered, like if we're doing like highly precise engineering applications, we don't use cron for it. Cron is not considered to be like a time, if it's a timing critical function, we do not use cron for it. Cron is perfectly fine for system stuff. All the stuff I do in the system space, I do not care if my antivirus kicks off at 3:01 a.m. or 3:39 a.m. The only time I would care about that is if backups were running at the same time. I don't want my antivirus and my backups running. But other than that, I wouldn't care if something ran 5 minutes late. That's within my, and I always compare this, and I know some people aren't gonna like this, but I compare it to like an AR and an AK. If any of you guys know what those are, I was an infantry guy, so I used an AR. ARs are awesome, but they can't operate with a single grain of sand in them. AKs are janky as shit, but you can slop them down in the mud and they're still gonna fire, right? You could literally take a clump of mud and throw it on the side of an AK, and that rifle will still continue to fire. But if you put a grain of sand in my little AR, it's not gonna fire. Well, M16, but you know what I mean. Civilian side is AR. However, that AK, I don't think that AK is reliable past like 200 yards for any kind of real precision. And my AR, I can hit with open sights out to 600 like nothing. That's not even a problem, right? For a normal upper body torso type target, right? So anyways, that's the difference between them, and that's kind of how I think of this. Like your cron is just not, it's not engineering timing precision. We use other tools for that, right? Let's do a cron tab -E. And it's going to ask me, how do you want to do this? Nano is easy. That's super funny to me. Nano is easiest. I'm going to use Vim Basic, right? Because that's fine. Shift-G, O. And at the bottom of this, it gives me my minute, hour, day of the month, and then day of the week. And I'm just going to add in this little... We're going to say at the 0 minute of the first hour of every day of the month, of every day of the week, run answers clamp scan. So at 1 a.m. every morning, run that thing that we just set up. And then if I say cron tab -L, I did cron tab -E to edit it. Now cron tab -L should show me that yes, that is indeed set to run. Now, there are other ways to run cron, but cron tab is probably one of the easiest. Where cron tab installs that, so this thing that it just said installing cron tab, it put it in var spool cron, and then it went one deeper, cron tabs, and then root. And there it is, right at the bottom of root is that clamp scan. So I just said cron tab -E, but then you're like, where did it put the file? And the file didn't exist before because it said it was making it. It put it in var spool cron tabs in an Ubuntu system. In a Red Hat system, it's var spool cron. So there's no cron tabs. But it is always the name. So the name of the user will be the name of that thing. And if you're like, man, my freaking users, they're always doing stuff, you could write a real quick little scan that just goes and runs var spool cron all through your Red Hat environment, and you can just, like me, I'm like that little trash panda, like that little raccoon that's like, give me all the garbage. He doesn't say garbage, he says garbage. I'm like, give me all the stuff, and I can audit all my systems very quickly because I know where it's at. And users don't have access to this, but in root can also write to, you have etc cron.d in here. And in here, you can define whatever you want, but there's a problem with this, and this is not a problem, but you got to decide where you're going to put things. Are you going to put them in root's cron tab, or are you going to put them over here and have them like system level? But stuff that's over here, now you can't just do this, because this is only when the user is already defined. In here, you then have to give who the user is. So let's just look at like if PHP has it maybe. And it says here's that same pattern, but here's the root user, and then it checks if the PHP session clean is there, and if it's not a directory, run systemd, and then it does this session clean and it cleans all of the PHP or whatever, right? But you had to add the root because I don't know which user to run. But only root has access to build this, so do you really want to? Yeah, so if I do an ls-ld, yeah. Oh no, anybody else can come in here, but nobody can modify those. Yeah, nobody else can modify those. Only root has access to modify those. But root could put some other user to run stuff out there. So I don't know. I don't like abstracting shit that much. If root's running cron tabs, run it in root's cron tab. That's my thoughts. But different people do it different ways in different companies, guys. And some government jobs just turn off cron. So then you have to go do systemd. You got to do systemd service timers, and those aren't super hard to write. I need to do a lab on those though, because people keep asking me for them. But look at you learning Linux. You installed an antivirus solution because of PCI compliance and the constant bickering and annoyance of your GRC team, right? It updated the signature database. You made sure that you had the most recent version. You set up a logging script on a cron timer. You did two different ways of cron. You dropped in cron.daily and it was standard, or you did it in a cron tab and did whatever the heck you wanted with it, right? Continue to use this as a sandbox to continue practicing with the tool. We also tested that the antivirus was working by adding this eICAR signature. And I showed you guys that you literally just drop that in a file, and then when you scan it, it'll be like, it'd be like that meme. That's bait. That's bait right there, right? This is bait. But your antivirus has to find it, but it's good because then you can see if your antivirus is finding things. We could have done, we could have done some fun stuff. I didn't even think about this. We could set up NFS and then squash this underneath a mount and then see if it still finds it. I bet it still would. But that would tell us how it's scanning. Is it scanning just by inodes that it can find, or is it also scanning like partitions of the disk? I think it wouldn't find that actually. So that would be a good test, but we don't have time in that environment right now, and also I don't care that much. But well, I guess we could set up NFS, but we don't do that now. We did NFS earlier today, so if any of you guys want to go play with that lab, you do have it. Not playing with this lab. He's part lab and part German Shepherd. So, anyways, all right. Let's go bust out of here. We'll go back. And, oh, you know what? We logged directly into this one, so that one's not even gonna, there. All right, so the next one's gonna be installing Slurm. Slurm is one of my babies, man. Like, I really like Slurm. It's a great tool to know if you want to get into high-performance compute. And I'm going to be adding more labs with this because I really want to show you guys how you can do accounting with this. But I just didn't build it before we finish the lab up, or before we finish the book up. It will probably eventually slide into the book because I think it's so useful. While we're getting ready to start that, though, here's Slurm Linux. I'm going to link this to you guys. So anybody that wants to do the lab can. And yeah, it is Slurm. So one of our junior engineers, she was kind of giving a presentation on Thursday, I think, to one of the newer guys, and everybody had to give like a 15-minute presentation to him. I had to give him an hour-long presentation, but that was because I'm the guy that teaches people how to get into the system. So I work on a system at a big college in the Northwest, and I'm the one that I drew the diagram when I got there last year, and now I'm the guy who does all the training on how we get in the system and how data flows and all that stuff. It's a clear example of the no good deed goes unpunished, right? Like, because I knew how to do things, I made it worse for myself. But anyways, so let me update that, because it's funny, like YouTube constantly gets further and further behind, and it's really funny. But yeah, okay, so now it's on the right stuff on the YouTube side. So we're going to do the Slurm stuff. It's pinned, and what was I saying? Oh, yeah, anyways, all through her presentation, it was Slurm McKenzie from Futurama. And if you guys are not familiar, he is the party worm, and he's always like, he's like, kill me. Like he wants to die because he parties too much. It's actually pretty funny. But anyways, all right. So let's get ready to start this lab. I'll give you guys a minute or two to organize your thoughts around that last one. If you wanted to, actually, I'll leave it here for a second because if you had anything about the antivirus that you wanted to keep thinking about, or if you want to write any of that down, feel free to. Because next we're going to do Slurm. And Slurm is a scheduler. Is not the only scheduler out there. I know that I have a bit of a speech impediment, but gosh, if this thing doesn't make me feel like an idiot sometimes. God, this closed captioning, like when I look at it, it does exactly what I think it's gonna do. But when I'm up here talking to you guys and I look down, I'm like, what the hell is that thing talking about? It'll be talking in like some other language or something. When I watch it, it goes back to being normal. But when I'm over here talking, like that thing's saying all kinds of stuff. So I apologize. Also, somebody caught one earlier. It said something about me doing. Oh, I don't even want to say that because then it'll say it again. But it had something to do with me and guys, and it was kind of awkward. But anyway, so because we were talking about wrestling stuff. But anyway, so let's go down here. And Slurm is a scheduler. And it says your team wants to set up a proof of concept around scheduling jobs across multiple nodes. The end goal is running a compute cluster that functions like a high-performance compute cluster. What we want to have is the ability to send jobs to multiple nodes. Those nodes would eventually have some type of back-end storage, so they have shared libraries and MPI or open MPI message passing, right, to be able to send information between themselves. Yeah, it was awkward, Inspector. It's in the Discord. Yeah, excuse me while I kiss this guy. Yeah. We do say it's only inappropriate if you make eye contact during wrestling. Yeah. So install Slurm and have the appropriate daemons running. So we'll talk a little bit about the architecture of Slurm. But first, let's update the system. Make sure that all of the repositories and metadata are good. It also says we have 171 packages that could be updated. We don't care about them. We're just going to install Slurm and the Slurm control daemon on this node. This node is going to run the cluster. For the purposes of this lab, this node is going to run the cluster for Slurm. By the way, while that's coming up, I want to show you guys Slurm architecture. This is one of the most important pages about all of this. So I'm going to link this to anybody that wants it. Also going over to the YouTube. And in case anybody's watching this later and wants to do it. And there's this really good drawing right here that I'm just going to right click and say open the image in a new tab. And then this is kind of the crux of what we're doing. We're going to have on any node that's in charge, we're going to have the Slurm controller daemon. So that's on control plane. Control plane is also, for the purposes of this very small cluster we're in, going to be running the Slurm daemon. So it's also going to be a compute node. So it's going to have two functions. He's going to be both in charge, but he's only got one other node with him. So he's also going to have to do work, and he can schedule work to himself and to the other node. So both of the nodes that are going to be scheduled to are going to be Slurm daemon nodes, and they're just going to be compute nodes, right? They're going to listen to the Slurm controller daemon as kind of what's going on. Oh, jeez. This was the... They only do geek, man. I haven't done no ebook all year. It's really weird. I've been doing just... They only do geek, man. I haven't done no ebook all year. It's really weird. I've been doing just... They only do geek, man. I haven't done no ebook all year. It's really weird. I thought I said gay men. They only do geek, man. I haven't done Alright, let's get out of there. Too much of that. Alright, controller daemons. So one is the controller, and then, yeah, that's it. So, we got Slurm going. Now, on node 01, we're going to install just Slurm, the Slurm daemon. So remember, control plane is going to be in charge, and both of them are going to be worker nodes. We don't use master and slave anymore in systems world. That you'll see that has all been ripped out. But we used to call things master nodes. Now they're mostly called control plane or control nodes, and then we call things worker nodes, right? Those are the distinctions that often are made nowadays, right? But this is a Slurm daemon getting installed on that other node. And then one of the things we have to do, because as we built these nodes, and it doesn't show it here, but it is something that happens in the architecture, the controller daemon, to talk to the nodes, has to use a tool called munge. Munge must be there to allow Slurm, controller daemon, to order around Slurm daemon. Slurm daemon is listening, but the key exchange between the two is used by the munge protocol. So, think about this real quick. If munge was installed on both machines, so cd to etc munge, and there's a munge key, and I can look at the key, right? I can't really read it, but I know it's there. I want you to think about this. If I installed it on some node out in the world, control plane, and then I installed it on some other node anywhere else in the world called node 01, do you think that those processes of installing munge would ever in a million years have the same key that could talk to each other? No. They couldn't. So, if we know that munge is the key, then we're going to do kind of like almost like an out-of-band communication here, where we're just going to copy the munge from this main machine control plane over to node 01. So now the munge keys are the same. And then on node 01, we're going to restart the munge daemon. So now both of these nodes are basically like, they basically have those little brain slugs on them from Futurama, and they're both like listening and ready to talk with the main daemon, the Slurm controller daemon, right? So I say, now that you have munge working correctly, by the way, you might say, well, don't I have to restart it on control plane? No, control plane came up with it right. We were making node 01 the same as control plane, so that's why we didn't have to do it back. We didn't have to restart this one. So I say, now that you have munge working correctly, it's time to configure Slurm. You may use the link here to build one in the web tool. This is a useful tool to look at. If you've never built Slurm before, you drop in here. This is called the configurator. Very clever name, right? Configurator. And these are all the things that you might want to set up. And let's say I call this Scott Cluster, Scott Awesome Cluster, and all my nodes are going to listen to. So who's my Slurm controller daemon host? It's going to be my P01 Jumpo 1 and my Homelab, right? Like all of them are going to listen to that guy, and it's going to be awesome. And then if I have a backup controller, P01 Jumpo 2 or something like that, and then if I have any compute machines, I can define them here. And when I'm all done setting up everything about this that could possibly happen, I hit submit and it builds a basic little config file for me. But this is a lot of information. We don't need that all right now. That's for if you go to do this in live production. In the lab, I made one for you. So we're going to copy it from this main node, and we're going to put it into Etsy Slurm llnl slurm.conf. I don't know what the llnl means, but in this free version, that's how it runs. And then we're going to go look at that file. We catted it out. It's a pretty short file. There are 5 things that I changed in this file for this lab. 5 things. Only 5 things from the original slurm.conf. I called it the Prolug cluster, so I gave it a silly name. I said the control daemon is control plane. So Slurm control daemon host is control plane. Both of those nodes have to be able to find that by a resolvable name. Lawrence Livermore National Laboratory, yeah. And then we're going to come down here, and here's the other. So those were 2 things. I have 3 other things that are coming up that I changed. I made a node name control plane line. So this is control plane, and it's got 1 CPU and a real memory of 1500, so we're not using all 2 gigs of its memory. Then I did this one, which is node 01, and then I made a partition name called Prolug, and I put all the nodes in it, and I made it the default one as well. And you could have multiple different partitions where you have multiple different sets of nodes, and those are going to be, you're going to allow users to run against those different partitions based on all kinds of things. You can do all kinds of things. This is a super simple lab, so I just changed 5 things. When I push this, so now I'm going to push this to both nodes. I'm going to restart their Slurm. They're talking. The Slurm controller daemon is now going to be in charge of both of these nodes, and they're going to be in the Prolug partition. So then I'm going to be able to schedule jobs to them. That's going to be one of the next things I do. So let's do this. Let's copy this file over to node 01. So it's from control plane to node 0, 1. And then let's restart it here and restart it over there. So here I restarted Slurm control daemon and Slurm daemon. On the far node, on the other worker node, it's Slurm controlled Slurm daemon. All right. Now I'm going to say status munge. Munge is running. And Munge is one of these services that it legitimately pisses me off. Because look at, and some of you are just going to be like, Scott, stop being so annoying. No, this pisses me off. It's Munge here, but it is a daemon, so there should be a D on the end. Oh, they know it down here. The name of it is Munge D, but the service is always Munge. Pisses me the F off. SSH always has a D on the end. It's the SSH daemon. HTTP always has a D on the end because it's HTTPD daemon. They know that this is a Munge daemon, so the process, the executable is Munge D, but they name their process service Munge. It pisses me off. All right, anyways, all right. Didn't piss me off that much, but pissed me off a little bit. All right, anyway, so then we'll go look at slurmd. Everything's running. Everything should be communicating. If this is complete, you have Slurm stood up on the cluster with 2 nodes. If we go look back at our architecture, the control plane is both this node and one of these nodes. Control plane is being both. Node 0, 1 is just one of these nodes down in the pool down here, right? So down here is both control plane and node 0, 1. And as a daemon, Slurm control plane is up here as well. So that's how this kind of works. It's super weird that they have these guys pointing there and not pointing up here because no nodes do this. That's super weird. They don't go off of it. Anyways, doesn't matter. That's weird. Check. So now that we've installed Slurm on 2 nodes and started the daemon, you want to verify the status of the cluster that you have. So if you've done this, you have now set up a Slurm cluster. You could go tell somebody in the high performance compute space, hey, I've been a Linux engineer for a while, I've been messing around, and I know how to use Slurm. And they'll be like, that's good. Better than somebody who hasn't done Slurm, so it may be something that you're looking for. Also, I happen to know that NASA is looking for Slurm capable engineers. They also want people that know Lustre pretty well. And there's at least 3 jobs in NASA that are remote that you could work in. My company, Redline, doesn't necessarily have them open right now. Let's see what Redline does have. I don't know what Redline does have open, but we just have the cloud lead open. This one's been hard because you have to be local to California for this one. Can you slurm your nets like nets your... That one's been hard for people to... We haven't been able to fill that role. And if I was willing to move to California, I could be that guy, but I'm not going to go to California, so... They'd have to pay me way more than they do now for me to even consider that. And I wouldn't leave the state of Arizona anyways, but... Alright, so let's do some... These are strictly Slurm commands now for a bit. And the Slurm commands are all these ones over here that control the cluster now. Okay? So show control, or S control, show config, will dump all kinds of information about system to the screen. This is way more than we could ever want to know. But we do now know it. We can throw that in somewhere. We can grep out just log. So where are all my log files at? Here's everything that looks like a log. So I tell you guys all the time, if everything works fine, you don't have to go into the logs ever. If everything works fine, everything's working fine. Like, go about your day. But if things break, that's when we have to bust out the logs. So I would rather know where the logs are now, before something breaks, than have to scramble and look for them later. But this is a way to find all the logs that this system thinks it's using. Here's where the Slurm control daemon is logging things if it can't talk to things. Here's where the Slurm daemon log on this node is, var log slurm ll nl slurm.d.log. This node, this Slurm wouldn't care. We wouldn't care that much about control plane if this wasn't also a control a worker node. Since this is a worker node, we do care about this now. We always cared about this file, because this file is very important on the control daemon, because now it's what can talk to it, what can it talk to. But this one's really critical because this guy's also a worker. He happens to be a worker right now. And in our cluster with 1,200 and something nodes, our control daemon nodes are only doing control daemon stuff. They are not also workers. You cannot schedule a job on our other nodes. Even if they're just chilling, we never ever make them do any other work. They're just running the cluster. Because they're the gateway for everything to come through, the schedulers. And the control daemon is truly the scheduler. So okay, so we did that. And then I say run the sinfo-n command to see the state of the nodes. Here we go. Here's control plane. Here's node 01. There's one node each. They're in the partition prolug, and their state is idle. Idle means they're ready to do stuff. There's a whole bunch of other states that they can be in. They can be in down, draining. They can be, I mean, there's all kinds, you can find them in all kinds of funky states. There's like literally hundreds of them. You can man sinfo, right? And then / for states. And I think we can find a list here of all the states that Slurm can be in. Let's see them there. I'm just hitting N. There's all the states. They can be allocated, comp, completing, down, drain, draining. Drain means that it's drained. Draining means that there's still jobs running on it, but it's not accepting new jobs. Drained means that it is drained, much like drain. But sometimes you'll see drain with an exclamation mark after it, or not an exclamation mark, asterisk after it. So it can be any of these other ones. Drain, draining, fail, future, future with a just R. Idle, maintenance. So we can put them in maintenance mode and then move them out of normal partitions that they might be in. Mix, no response, NPC. Some people are NPCs anyways, right? Perfectors, power down, powering down, power up, reserve. I've never seen a bunch of these. But I would never put it past the crap that goes on in our cluster that some of these might just happen, right? There's weird stuff that happens. Hey, by the way, Mario, hopefully this stuff's useful to you. Thanks for the follow. You guys probably know follows are free, so I appreciate them. Hit Q, and you can do sinfo-N1, or I think that's an L actually. Yeah, that's an L. That will give you more information if the nodes are down. When I was first testing this and building this, I was having problems getting them to communicate. And the reason they were not communicating is if we cat out our slurm.conf. The reason they were not communicating correctly is this was the node name in each node. It was not control plane. You have to have everyone has to believe that the one is the leader. If they don't all believe the one is the leader, how can they ever talk and listen to the scheduler properly? They're all thinking other nodes are the leader. So I had to change that to control plane, and once I did that, everything worked. Also makes sense, right? Okay, so now we've got the cluster built. We've tested it to see the state of it and make sure things are working. Now we're going to run some jobs on it. We're going to run a simple job against one node. We're going to run a simple job against both nodes. And then we're going to run a batch job against one node. Simple jobs, which are what we call synchronous, they are not the way that we will normally do things. Sometimes testing, engineers and scientists and stuff will do these to test things. But typically a batch job, which is an asynchronous run, will be the normal way that we do things. By the way, synchronous means I'm going to send it off and then I'm going to sit here like this, twiddling my thumbs until you come back. That is only going to be for short jobs and tests. Asynchronous jobs are going to be where I batch something off and send it, and I don't expect that output for weeks. We have jobs running in our cluster that they do not expect to actually finish or to complete for over 3 weeks. You might say, really? Yeah. You got to shoot a good azimuth. You got to test your code to make sure it works, and then you run against massive data sets in some cases. Yeah. And we have, I've explained this to you guys, I have many tens and hundreds of petabytes sitting out there of data that's been brought in, and all kinds of stuff that we do, right? But this is how we're doing the smallest little version of this to look at it, but these are the things that then grow up into very big things in clusters, right? All right, so anyways, let's go look at this. srun-n1 hostname. So against one node, we're just going to run a host name. And against that happened to go to control plane, right? And then against two nodes, let's run a host name. So it went against control plane and node 01, and that makes sense because we have two nodes. And then let's try to run against 10 nodes. And we're going to have, that's not possible. I'm going to go ahead and queue it up until we have 10 nodes available. That's not really a good way to do it. This should have just churned through pretty quickly, But this is good behavior to know. If you ask for 10 nodes and the partition can't give it to you, it'll just queue it indefinitely. There are ways around that, and there's other things we can do. But for now, this is going to just sit here until I stop this, right? I said, how did this behave differently than what you saw in the other commands? You may have to kill this command with Control-C. Does it make sense that you tried to schedule against more nodes than you had, and the system did not react well? That's true. And it's because srun is waiting until everything's there. So now we're going to run some batch jobs. We're going to run a batch job and see kind of what this looks like. So I made a file for you called a root submit.sh. This is the format that we will send sbatch commands in. This right here, you can Google sbatch examples. You will find very, very few of them. There are not many of them, but they're pretty simple. It's got the job name if you want to give it a simple job name. You can job name scott.date, whatever. The output is going to be root result.txt, but that might be into my home directory instead. I'm probably not going to be root as I kick this off. I select my partition if I'm allowed to select a partition, but I know that I want prolog. My time is going to be limited to 10 minutes in the cluster. You can, when we get into accounting and some of our other stuff, not in this lab, but in another lab that I want to build, when we get into accounting, we can set the maximum wall clock time that people are allowed to use, and we set things by default to 10 days. You say, wait, didn't you just say earlier that things will sometimes take 21 days or longer? Yes, but we can also give special, and some people have grants and stuff in our college, like they have grants from projects, so they have buy-in nodes that get added to the cluster, and they get first dibs on those. But then those buy-in nodes also become part of a pool that other people can use when they're not using it. And we can also give them general access if they need more. If they're like, give me more power, give me more power, we can we can give them more of the system, right? And there's all this stuff. Anyways, we're going to give it one task. When we do n tasks, that's how many nodes it can go to, and then how many CPUs per task. If you pick more CPUs than some of the nodes have, it will not be able to go to those nodes. So that's the thing to limit. And then how much memory per CPU? We're limiting it to only 100, but there's 1,500 possible on these nodes, if you remember from the configuration earlier. And that's in megs, right? We have 1,500 megs, which is 1.5 gigs. So we could actually run a few of these at the same time in our cluster, the way we have this configured, right? All we do in here is we do an srun hostname, and then we sleep for 60 seconds. That's all we do. And we do it against one node. We could also do it against two nodes. All we'd have to do is VI this, and then say, give me 2 tasks. So I'm just going to change this to 2. Escape : WQ, and we kick that off by saying sbatch root submit.sh. So we kick off with sbatch this execution right here, and then immediately after that we go and we look at the queue. So now we've got this queue running, and it's going against 2 nodes because I changed it from 1 to 2, right, just to do it. And then I can go look at my cat root results.txt, and it went against control plane in node 01, and it did the things that it was supposed to do. I said, was this output what was expected? Also, by the way, if I do a queue again, SQ, is it still running? Yes, because it's still sleeping right now. And then we could have it do something after as well, right? But all we had to do was srun hostname and srun sleep. But there's very complex examples of these, and then when we share libraries and have back-end storage, and we have our libraries all, we use a tool like SPAC that will put the same exact libraries on all of our machines. We can have things where, nodes can be, there's all kinds of things we can do with this, but this is the basics of it, right? Yeah, this is the basics of it right here. There's a lot of stuff that you guys can do and play with and that kind of stuff once you get a cluster up and running. And I meant, man, I think I was saying back in September of last year that I was going to get a cluster running. I have a cluster running in my home lab, but I just never gave access to everybody. I called it C login. That's the main. So the controller is Slurmo1, and then my nodes are here and here, and then down in here, right? Wait, are they down here? Are they here? I don't know. Anyways, but the point is I had all these nodes. I just don't have them on, and they're all built and they all run. I just never got around to, because what I wanted to have was people within the professional Linux users group community that wanted to kick off jobs and do stuff like it was a real high performance compute system, they could do that. So I have these nodes built out. I just never got back around to it. You guys will find out that sometimes I get squirreled off in different stuff, right? That's an engineer thing, I think. And then here we said, look at you learning Slurm configurations. You installed a Slurm scheduler or a job scheduler called Slurm. You ran informational commands to see node readiness, and then you scheduled simple and batch jobs against the system. So you did a bunch of things there. And then once you have that cluster up, you could go to the Slurm MD and go work through. They've got labs in here and all this other stuff that you can do, but all the things that they have in here are based on you having a cluster up. So you could do this lab, and then you can just go in there and play with your Slurm cluster because it's your cluster for the next hour, right? I think the stand-up of that only took about 5 or 10 minutes. So then you got 50 more minutes to go in here and do. They have, maybe it's support and training. I think they have a bunch of, you can pay them, but just the free stuff here and the documentation, you can go watch and look at stuff and then start to look at some of the other stuff that's going on. But the point is, at the end of the day, like, you have to get the first part working, right? I always tell you guys, like, get the first thing running, and then you can go play with whatever you want, right? All right. So I'm gonna leave this up here for a minute. There's our Slurm lab, right? You guys did Slurm if you did it with me. Probably not as many people did it with me, but if you did do it with me, there you go. You should feel very good about yourselves. And I'll take a real quick break again. Fill my little hourglass up. Where's my hourglass up? Then we'll decide what else we're doing. I'm going to say, Watch Ranger. Think about lab. Slurm lab. Watch Ranger. And we'll just say 8 minutes. That's my normal break time. All right. Go walk around for a little bit. Feel free to stretch your legs out. And then we'll come back and maybe we'll do some more labs. Maybe we gotta do some Homelab stuff. But I've been kind of I can feel myself putting off stuff I need to do. I have stuff I want to build in my Homelab that I just haven't done. And maybe I can do that next. I don't know. We'll figure it out. There's always more lab time tomorrow. Sunday mornings are always all labs. I don't do anything but labs on Sunday mornings. But yesterday and today we have been doing all the labs in the book, all the labs that we have out there for you guys. So, all right, think about the lab. We start this. Here's my break. All right, I'll be back, guys. I got a call with the wife too, so that was good. All right, I'm almost done. Breaks. We got 4 more minutes. We'll get back to it. Doing labs. Lots of stuff we can do.
Whatever dreams you're chasing.
Her dreams. That was from an ad. Well, ad was trying to pop up on my phone. All right. Ranger's just not having any of it. Look, he's not even. He's just laid all up in that bed. He had a long day of laying around all day. Now he's going to do some more laying around before he goes to sleep for the night. That's what Ranger does. Also, I haven't went to intermission for a long time. Let's go to intermission real quick. Yeah, there's a little intermission. Tells you to practice your loops. I don't think I've been to that for, man, I don't think I've been on that in a long time. Tells you to practice your loops. That's all my intermission ever does. That's amusing to me. In case you guys didn't know. Alright, let's come back over here. Throw that monster away. I don't need none of that. Any more of that tonight. Pop myself back up on here. Ranger is doing Ranger stuff, so there's that. And yeah, let's look what the next lab is here. The next lab, if we just keep going, starts to get into the security stuff. But let's go over here because I think we're skipping one. I think I have one after Slurm, but that didn't make it in the book. Yeah, there's one after Slurm that didn't make it in the book the other day. So it is the server startup process. So we're going to do this one next. So this one's not actually in the book anywhere, so it's okay. We will we'll skip the book for now. And we'll move that down. Move this across for now. Bring the book back up later. Alright, you guys still got a few more minutes of break before we go. If I ever bought Code Cloud or recommend it for DevOps, I think Code Cloud's really good. I never bought it, but back in the day, I don't know that it's still like this, but Mumshad used to have all his stuff on Udemy. And if you bought his class on Udemy for like $20, then you got a Code Cloud link. So I have Code Cloud. Like I can go into Code Cloud. And it's just logged in directly through my my Gmail. Let's see. Or my Google, right? So it should just connect me right in. And then it has that because there's not all the courses anymore, but I have courses in here. I think this is an excellent tool, and I think Mumshad's one of the best guys around. I should have. Let's see. Yeah, I have things that I've picked up from them, but I never actually bought anything. You just used to get stuff. You just used to get like keys when you bought their Udemy courses back in the day. And when I say back in the day, a couple years ago, I don't know that they still do any of that. Like I bought this one when this guy first put this out. I bought this because I thought I was going to do the Vault Operations Professional, but I'm probably not going to do anything else ever again with HashiCorp. So Vault is still an awesome tool, but I don't know how much I'm going to keep playing with it. You know, when it's, you know, just that it's just novelty for me. But no, I think in general, like that's one of the best things you can spend your time on is. If you're going to spend money, Code Cloud's a good place to spend it, I think. So, let's leave this open like this. All right. So this one never made it in the book. But this one talks about you're a new system administrator at a company, right? This is very common for all my labs. You've been tasked with the process of building out new servers. You would like to gather information about the current systems to see how they start up and what's currently on them. This does not mean when you're building out new servers that you're going to use all the old stuff. It's just that you maybe are looking for like a baseline, and maybe you're looking for just kind of things that are happening with the servers, and maybe you're looking for tools. There's one that gets me literally every time. I built a server the other day for one of the guys at work. He wanted to rebuild something as Red Hat 8.9, and our baseline is 7.9 in one of these environments for Red Hat, and we went to 8.9, and he needed it on GPFS, which is the global the general parallel file system, which is an IBM tool, and he needed it on there. But for me to get it on there, I needed to install OFED and get the InfiniBand up, and then I needed to get the GPFS working, right? And GPFS, this is the weirdest thing ever. It will not run on a Linux system unless you install Kshell. I always forget that shit. That is a dependency. You must have Kshell on your Linux box, or the installer for GPFS will not work. The RPM and the installer that's inside of it will not put anything on that system. It'll go, nope, no Kshell, can't run. Isn't that weird? Like Kshell hasn't been the standard on a Red Hat box for sure for 15 years. It was never the default, but it's not even really on there anymore. But you can still install it, and you have to install it to get GPFS running. You have to. There's no way around it. What's going on here? Somebody's messaging me. Wife's messaging me saying she loves me. That's funny. All right. That's always good. She's at a scrapbook retreat. She builds like little scrapbooks. In fact, the room behind me is full of two things. You guys know what? Does anybody know what the room behind me is full of? It's my wife's stuff. But what are the two things? Does anybody? I say this often on stream, especially since I'm home here by myself, just me and Ranger. What are there's two things in my wife's scrapbook room behind me. It's directly behind me there. Creepy ass dolls and a bunch of scrapbook stuff. She's got a wall of dolls, guys, and they are scary. So I always tell you, if right here a little doll ever pops up behind me, like let me know, right? Like at least give me a few seconds of time to, because they're creepy. All right, anyways, all right, I'm done with that. But my wife was texting me, so you're a new systems administrator company. You're tasked with building stuff out. You find yourself at a command prompt and need to find out how the system started, what processes are running, how they were started, what ports are exposed. Again, you might not use all of this, but you want to know the porn and mag. That's what's in my room. That's what's in this room here. Anyways, what kernel version and startup parameters were used for this system? What hardware does your system currently run on? What's the processor, the NIC, the virtualization? All of these things. Use the solution if you do not know the correct answers. Or if you just want to challenge yourself, don't look at the solution. I am not going to challenge myself. I am going to look at the solution. So we're going to cat Etsy Splat Release and see that we're on version 20.04 of Ubuntu. Maybe your task at work is to move you up to 22.04, or I think 24. Somebody told me 24 was just released. Is that what's the newest Ubuntu release? I think somebody said 24 was open just the other day. 24. Noble Numbat, huh? They picked the weirdest, stupidest fucking names. All of the Linux names are this. Anyways, desktop image. When did this get released? Does it say? I mean, I tell you for sure that's stupid, but the name is stupid. Anyways, here's the stuff. And also, whenever you download an image of any type, here's your server install image, you can always get the MD5 hash of it, right? So here's the server install image. Oh, I don't want to start. Let's do that. But we could get that started to build into our lab and then start to have that as servers that are up on our lab. Netboot tarball. So if you want to do netboot, netboot's a pretty common way of us booting out of like XCAT, or when we want to build things up as stateless images, we use netboot images typically. So installer over the network. If we want servers that people can build and work on, and then when we turn them off, they go like this and come back up as a clean server again, that's typically what we use netboot for, right? Not super common in the industry, but it is kind of common in the high-performance compute world. Ooh. Inspector, ooh, man. I looked at that and I was like, is this April 1st? I was looking at Kubernetes and I was like, what the ooh type shit. All right, anyways, I'm not gonna get started on that. Catproc command line. Here is how this system booted. April 17th. Thank God it wasn't the first. I would have expected that on the 1st, but not on the 17th. All right. So again, I tell you guys sometimes I look at things like the command line of how a box was booted, and I'll go hit a bunch of servers and then bring back all that information. And if they're all the same, we're good. But if they're even varied in any way, the kernel version is different, the way that we called it, that server was probably built with some other process than my automated one. And this is one of the ways when, if any of you guys have ever seen like a sergeant stand out in front of his formation and everybody's standing and he looks up and down the rows and he's like, Private whoever, suck in that gut, and Private whoever, why are your shoes all messed up? It's because when you look down a row of people, it's very easy to see. It's very easy to see who's out of, whatever. And it's very easy as you step down the line to see if anybody's standing like this or if somebody's got their hat on too high. Or it's very easy to see that stuff when everything's in line. And this is my same idea with when I go check out my servers. If anything is stepping out of line, I just rebuild it so that everything looks the same. It's like a dystopian novel, right? It's like, oh no, God, you're killing, everybody's the same and you kill anybody that doesn't look the same. I do that with servers. I 100% do that with servers. And you're like, the genocide of all the servers that are aberrant? Yes. I will kill off any server that I can that is aberrant from my baseline. Yes, 100%. I'm a madman about that. Because here's why. Every one of these servers is easy to keep in line. I know exactly how it was built. I know exactly if I run an installer across all of it, it will either break on all of them or it'll work on all of them. And I love that. I don't want anything stepping out of line. You might say, Scott, you're a madman. Yeah, with my servers, I 100% will accept that. By the way, this happened with my college students the other day. I have one, if you go look my name up on ratemyprofessor.com, there is one student ever who complained about me. I have no other good or bad on Rate My Professor. I have one, I found him the other day, it was like in 2019. And he said, Scott is too hard on us. I said, I'll take that fucking thing every time from somebody. I was too hard on you? What do you think the industry is going to do to you? This industry will chew you up and spit you out, right? Like, I'm going to be hard on you because why if you hate this stuff, why would you be an engineer? The best thing I could give, let's say there's actually 32 people in here watching right now. The absolute 100% best thing that I could, like, of all the things I could give you here, I could show you Linux stuff, I could do all this other stuff. But if you watch this for an hour and you said, I never want to touch that stuff ever, that is the absolute best thing I could give you. And you say, really? And I say, yeah, that's the best free life advice you ever got. You're going to spend 30 years hating this? You probably get paid pretty well, let's not lie. But if you're going to hate it your whole life, why would you want to do this stuff? I tell students that all the time. They're like, I hate this Cisco stuff. And I'm like, you're a network engineer. You literally are going to live at that command line right there. And they're like, oh, I don't like any of this. I'm like, well, go into medical then, right? Like let people bleed all over you or whatever, whatever. Like, there's always the infantry, guys. You could always go back to the infantry. That was never an option for me. I was like, I am not fucking going back in the infantry. I'm never doing that shit again. All right, anyways, let's look at how this server booted. All right, I'm getting loopy because I've been on too long today. But D-message, head. Now we see another thing about how the system booted. We can see errors in here. But I can start to gather information about the system. I can do D-message, and I can look for things. So grep-i eth. And see if I can see any Ethernet information. And I showed you guys this before. From here, I've shown this before. ETH, I can see this virtio.net, and then I do like an ls mod, which lists all the mods. grep-i for virtio.net. And I see that virtio.net is there, but it's also a dependency of net failover. So net failover is using virtio.net. So I couldn't remove this if I did an RM mod on virtio net. It won't remove that mod even if I wanted to. It wouldn't. Oh, maybe it will. Well, it did remove it, by the way, and now I'm not in the lab. Networking's down, guys. It shouldn't have removed it. This isn't going to be able to connect either. That system's hard down, guys. Anyways, I didn't think it was going to be able to remove it because it's a dependency. Typically, you can't remove it. But I just basically pulled the plug on networking in case anybody was wondering. That's kind of funny. All right, so we restart the lab. I'm loopy because it's too late at night. I'm not normally on this late. I don't normally have... I'm not normally left alone this long either. Like, the wife's been gone for a few days, so... we're kernel version and startup parameters. So we did all this stuff. Let's go down here. Don't pull the system out again. Cat pocket command line, dmessage head. We do the vert what, and vert what will tell us that we're on KVM. KVM is a type of virtualization, right? So we know that we're on a virtualized server. We can also do a DMID code and look for virtualization or prod, and we would see that we're on KubeVirt, and the product family is KubeVirt. So we know we're on a virtualized box from those. So that's good. That's we're gathering good information. We're finding out a lot of things about ourselves, right? So it says, what do you see in the DMID code? Anything interesting? What might you capture from the commands that will help you out in building a new Linux system? I see all kinds of stuff here that's useful. It's a virtual machine, so I can't guarantee that a future virtual machine is going to have these same things. But if it was a physical box, I would know that these are going to be the same when I re-push my new provisioning or whatever. All right, so I hit check here, and I say, now it's time to look at the running processes and evaluate how this server right here that we're on has booted up. So let's clear this up, and I say evaluate how long the server took to come up from the time that the kernel was called. Evaluate the startup process of the SSH daemon. How did it start? What are the dependencies? List any failed services during the startup, and then what exposed ports do you see and what software is listening on these ports. So we come down here, we do a dmessage more. We see some of that same information about how the kernel started at exactly the 0 time. This is kind of like D-Day, the time that something's going to happen. This is the 0 second of the Linux kernel being called. And then these things all happened within the first second. When did we get to the end of the first second? Right, I'm going page by page. Right here was the end of the first second. All that other stuff happened in the first second of this kernel being up. Then we started coming down here, and we started to load different stuff, loading certificates. And then we come down here, and we probably walked the system bus and started to turn on drivers and those kind of things. We can see all kinds of things that are happening in here, right? And we could search for those things if we want to once we're in here. But we're still only at about the first, right here, we're still only at about the first 3 seconds of the kernel. And then we started handing off to these other things, these other handlers. And then we started to do some of the app armor and turn on some security stuff. And then we got up to around the 10th second of the kernel being up. And we started handing stuff off to whatever this audit crap is. And all the way up to the 22nd second of the kernel are all these things that came up in the ring buffer as the system turned on. So that's good. You know, that's useful to see. And I say, can you look in the Ethernet? There's our Ethernet. Let's not rip that out again. We'll have to start the lab over again. And then our ls mod to look at that virtio.net. Again, don't pull that out. It's being used. And then this is where we really start to say, I like systemd analyze time, because it tells us how long the whole kernel took until the system was ready to run. We got to graphical target in 9.02 or 9.082 seconds. We've seen that take in the lab here up to like 15 seconds, but for the most part, that's about what it takes. There's some kernel time, and then there's user space time, and there's our aggregate time there for the whole system to come up. Do I think systemd can print you a Gantt chart? Maybe. There's actually something similar, not exactly similar to that, but let's look at systemd analyze blame. So what took the most time right here? Now, these are not in chronological order. These are in size, amount of time that it took, and you'll also note these are obviously coming up in parallel. And you say, well, how do you know that, Scott? Well, because the entire time that this took to come up was 9.082 seconds. But when you get to here, and here, you're already over 9 seconds. So these can't be happening serially. These have to be in parallel. But they are ordered by the thing that took the most time down to the thing that took the least time. So if you were like, hey, how can I speed this up? You probably don't want to be down here mucking around with these, because you're not going to get a lot even if you do get rid of them. You're probably going to want to look for some stuff here that you could either tweak or take out. You know, the ManDB service, does that need to be there? What the hell's that doing? And here's another thing. If it doesn't belong to any critical path, it might not matter anyways. It might just been something that happened off to the side. But I can tell you that if you work on getting these smaller, I don't need Docker. Get out of here. I don't want Docker in my dev systems. I don't need this udisks 2 crap. I know what disks I have. I hard code them. Boom. Get out of here. Snapd? Not in this economy, right? Get out of here. Have you guys heard that the not in this economy is the new no thank you? I heard that years ago, and it's always stuck with me. It's really funny. Like somebody's asking you to buy something, you're like, not in this economy. That just basically says no thank you, but without the extra steps. So let's look at this real quick. Let's we looked at all that stuff, and then we look at the status of the service SSHD, and we see that it's running. We see some information about how it started up and some different processes that are running with it, and that's all good. We can then come down here and say, is this enabled? We can see that it's enabled right here, but if we wanted to see that kind of faster, we can go right here and we can see systemctl is enabled ssh.service. It is enabled. Okay, good. And then this is one of my favorite commands right here. We're going to look at the SSHD service for the critical chain. It's read from here back to where the system started. These are all the things in order and all the dependencies that were needed to get SSH as a service running right here. SSH service. Isn't that cool? If any one of those things broke, we would know. We also know the time at which it started right here, and we know the time that it actually took, the added time that it took coming up. So there's a bunch of information here. And if something was broken, we'd be able to go look at why it broke, right? This is that idea of troubleshooting, like know where things, know how something's supposed to function so you can see where it breaks, and then you can use that to figure out where you need to go, right? So then I say, can we see what is enabled? Here's all the enabled things over here on the left. All the enabled things, if they're static or enabled. And then we go down here and we say, can I just count them up? There's 324 things that are showing up there. And I say, wait a minute, can you just run this and then count up how many of them in this second field here, so this field here, how many of them, because this one doesn't really exist, that's the first field, that's the second one, and then count them up for me. So there's 18 disabled, 94 enabled, enabled runtime, generated, indirect, masked, and static. Those are things. And then if you were like, well, can you find any, just if you just wanted the generated ones, you'd come here and you would take this off, and then you would just here and you would grep -I for generated, right? And actually you would take this off because you don't want that there anymore. And then there you go. There's the three. The 3 generated ones are right there. I don't know what that generated means. I'd have to go dig into that, but I can find all this stuff out about what's going on in the system. Again, I don't have any of this stuff memorized. I can go look at it when I need to, right? I know the commands because the commands show me this stuff. Then I say, can you show me the SSH package? Because I want to have at least this package on the new server that I'm building, right? So there's our SSH client. It has to be at least 1.8.2. And maybe, since we're going to a newer version, we're going to expect it to be different anyways. But I can still capture this, go throw it over in a notepad, and compare them after I build it. That's still something I can do. Why not? Why not just make sure I have a newer version, right? Save myself some trouble. I can look at everything down in etcSSH. These are all the configuration files about how SSH is configured. So I can see if in one of my clusters we have an SSH config and then an SSH secondary config, because we have an alternate port to get into all of our servers, just in case the normal port goes down for any reason, which it sometimes does, right? So we check that and I say, now let's look at what system ports are open and what software is running on each of them. You will need to determine you will need to determine your future build whether or not all these ports are needed, because sometimes things aren't needed anymore. This is just checking what is currently set. So we come down here and we can look at all kinds of stuff. Look at all this. Hold on. Make that a little smaller. I'll clear the screen and then run it. And here are all the things. Here's all the UDP connections. There's 5 of them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. And then here's all the TCP connections. There's 8 of them. I can see what address they're listening on. Are they listening only on the local host, or are they listening to everybody? And then what port number they're listening on. I can see how they're communicating. Here's our bunch of zeros and 40200, and then something like 000 on port 22 means anybody can connect to this box over IPv4 on port 22. Then this means any IPv6 address can connect to this box on port 22 as well. So some of these things are local only, which is this like 127.0.0.1, and then only local. That's unconnected. That's where the KC terminal is coming from. No, that's the system D network. Sorry, that one. That's my IP address, so I can only connect to my own thing on that, on port 68. So we can see what's going on is the point. We can look at port 53 and just see what's listening on port 53. 53 is only local, but it's the system D resolver, right? And then I can go look at that, and I can see how that thing was started in my system if I wanted to. I can see how the resolver was started. I can see what this is the path right here to the resolve D service, and this is all the things that happen. I can go read about it if I want to, and then what happens when I start it or stop it in the system. Here's my exec start. Here's my exec start right here. This is how it starts, and then my exec stop could be in here. If exec stop is not in there, then it just kills it. But if exec stop is in there, like if you need to bring something down clean, you can. But then there we go. You can continue this for all the processes, but what is currently running on your system? This is useful for you to enumerate so you can verify that you have basic functionality on the new servers. So new servers should look something like this as far as open ports. Maybe they're a little more locked down, but for the most part, you got to be able to SSH into them, and you probably got to make sure that you're able to whatever this KC terminal, this is their control port in. You should be able to check that kind of stuff. It says, look at you learning Linux. You've looked at the system startup. You've looked at the system D daemon and how the processes are configured. You've looked at running software and open ports. This will help you decide what you need to move forward on your new server builds. What processes do you need to keep running, and what software you want to allow are still to be determined, but you have the tools to see what's currently happening. It's very important to be able to look at a server holistically and see kind of how things started and what's running and what's broken, what tried to start but couldn't. All these kind of things are bundled up in all these commands we just did there. So it's very valuable. Very valuable as a systems engineer, system administrator, right? All right. So that's that part of the lab. Let's go pull this up. The next one that we would do, if we were going to keep going tonight, would be the attempted user login. But I think I'm at like 4.5 hours. I'm probably pretty beat. What are we at? We're only at 10:20. I could probably keep going. But no, let's stop here. I'll be on tomorrow. I'm also going to be doing some work stuff, and I've got some lab stuff to do in my home lab. I've been putting this off. I meant to do it all this weekend so far, but I have just been streaming and messing around instead. So, how about this? We'll do labs on Sunday morning, and then I'll take a little bit of a break. Maybe I'll even run the HPC video for people that want it, and then we will dig into maybe even I'll do some work stuff. I have a plan to maybe do some work stuff on stream too. Stuff that I can de-identify enough to make it valuable for you guys, but also to see how we can do a big deploy with Ansible and all that stuff. So, because guys, I'm telling you, this Linux stuff is great. This is ground floor stuff for being a systems engineer, but a lot of the automation that we do in Ansible is really where we kind of shine as engineers. A lot of the engineers that I've worked with know this stuff, but a lot of that automation stuff can really give you guys some value to your value prospect to the organization. So, all right, let's go to our little end of stream thing. Let's find somebody to raid, see if maybe somebody's doing something fun out there in the world. Let's look at who I'm following. Hold on, I'm going to my following again, and what's that? Same category. I don't have anybody necessarily there. Let's go find. Is anybody doing anything fun? We can go raid the Flat Earth. Nah, we won't mess with those guys. I was gonna find something fun. Looks like there's some chatting between some bots. We don't need that either. Let's go find something of similar size and maybe in the same category. Yeah, I don't know any of those guys. All right, let's go. Let's go raid Rob. We'll just raid Rob. Rob's always doing fun stuff. It looks like he's recording some stuff, but he's also talking, so we'll just raid over there. I appreciate you guys coming. I will see any of you that stop back by tomorrow. And yeah, thanks guys. I will talk to you guys then.